PySpark real-time scenarios in the data engineering interviews decides your selection. So this 3 hours long video will cover all the latest PySpark real-time scenarios for 2025, including handling schema changes while incrementally loading the data, Spark structured streaming with delta tables, implementing slowly changing dimensions using PySpark code, import and export of PySpark code, conditional column, window functions, changing frame clauses, identifying data skewness in PySpark. And do you know what? PySpark real-time scenarios are incomplete without Python proof concepts. That is why this video will cover building Python class to handle redundant functions, parameterizing PySpark code using loops, error handling using try except methods, adding multi-level conditions to build deployable PySpark code. So bro, I have put a lot of efforts to actually create this solution for you, and now it's your responsibility to shower love to this video, do comment on this video, to share this video so that maximum people can get benefit from this video, and just make this video a big hit. And now let's get started. So what's up, my data fam? What's up? Another Sunday, another amazing video. Because let me just tell you what we will be learning today, because this video is really special. Obviously you have just watched the introduction, so you know like what are the stuff we will be covering in this particular video. Let me just tell you a little bit in detail, so what will be the agenda of today's video. So as you can see, the OG of today's market, PySpark. Every interviewer, every data engineering role, every single role in the world of data engineering requires this skill. Why? Because this is independent of cloud technology. So you cannot say, hey, I am from Azure, I am from AWS or GCP, so I do not need to learn this skill. No, this is an open source. So you have to learn this particular skill, which is PySpark, this particular technology, which is PySpark. Okay, so obviously we know, like in this particular video we will be looking at real-time scenarios, but what is that particular differentiator in this video that makes it special? Let me just tell you. So I got so many requests regarding Python, and it makes sense because right, in the real-time scenarios, in the interviews, interviewers ask Python questions as well, but they do not directly ask you the Python questions. No, they do not. What they do, they just create the scenario, then they will just test your Python knowledge. Then they will just test your Python knowledge according to that particular scenario. So all those scenarios in which your Python skill will also be tested, all those special interview questions which are strongly based on real-time scenarios, basically I have already created a dedicated PySpark interview question, so you can definitely watch that video. I will just show you the link of that video, don't worry. This video is not just about questions, no. These are purely based on scenarios which can generate hundreds of questions. So once you know the concepts, once you know the working behind those real-time scenarios, you can answer any question. You can answer any question. So this is like your pure real-time scenarios video, and trust me, in this particular video I have covered all the latest scenarios, and I will not give you a spoiler, and you will get to know why I'm just talking about this video with so much of hype, because this hype is real. This hype is real because I have just covered all the latest tools and technologies that revolves around PySpark, Delta Lake, Autoloader, everything. This is not just a spoiler. I was just telling you a little bit so that you know what exactly we need to learn. Then when I say I have also included Python, I have included real-time scenarios which will test your Python skills. Okay, even if you do not know much about Python, you will understand it and you can just actually implement those scenarios and you can just become better in your Python skills. Okay, sorted. So Ansh, Lamba, we know that this video is a blockbuster hit, because of the uniqueness, because of the differentiator that it introduces in the market, because this is like pure real-time scenario. Trust me, these are not just like your simple transformations. Hey, just convert this column from integer to string. Hey, just add a new column which will just create blah blah blah. No, these scenarios are like your will blow your mind. Trust me. And these are the scenarios which can be asked by the top companies, because they do not ask just like simple questions, right? Because in the top companies you cannot expect you will just only have one or two rounds of interview or technical rounds. You will have multiple rounds, and these particular scenarios will be there. I'm so sure, I'm so sure, either in the technical rounds or maybe like in the one-on-one round, because they will just ask these questions. Why? Because these questions are like their bread and butter, because these scenarios are the, you can say, the center point of their whole working, what they do in the organization. So when they will be hiring you, they will expect this thing from you that you should already know, because you will be tackling with these scenarios in your day-to-day job. That is why it is really really important. Okay, so now you have like all the clarity about the video. Okay, so just take out your notebook and your laptop, and let's start tackling with these scenarios. So before doing that, let me just tell you, to continue with this video, we will be using a free community edition. You do not need to create any Azure account, any AWS, any GCP account. No, we will be directly creating our Databricks account, which will be a community based account that do not require any kind of, you can say, hassle to actually start working with PySpark. So that is the best place to create your Databricks account, and let's actually get started with the PySpark working and with this video. So I will just tell you everything and you don't need to worry. So what will be the prerequisite for this particular video? Actually, just the basic understanding of PySpark, and I would say this video will test your fundamentals, your coding, like everything. And you know me, right? Even if you do not know much stuff, you will understand as along with the video, because I will just explain each and every stuff from scratch and in detail, because I want you to learn everything from scratch so that you can just answer any question in your interviews. Like you can act, even if it's not just about like interview questions, when even when you are like hired, you need to perform these things, right? Then only you will be growing in the company. So I want you to learn, I want you to just do these things and just solve the problems in your organization with the PySpark, right? So that's why it is not just about interview questions. No, let's talk about the real time scenarios that can be asked in your interviews as well. So that is a byproduct of this video, but the main intent is to actually work with PySpark, bro. You should know, you should know even after you have like cracked your interviews, because no one will like spoon feed you. Hey, you need to just tackle with the scenario like this. No, they have hired you, they're just paying you to do all these stuff. You should know this. Okay, so first of all, I would love to welcome my loyal data family members who have recently joined me. Welcome Tata Rao, welcome Anupriya, welcome Thyra Ditch. So sorry if I just pronounced your name wrong. So with love, I can simply say like Thera if you love that. So Chiluka. So these are my loyal family members who have recently joined my channel, and thank you so much. It feels so good when you just support me, because obviously we already know that what is the situation of the market currently. Like people are like charging thousands of bucks to actually just provide so-called education, and you already know the quality of education, quality of value knowledge they are providing to you. And if someone is just doing his best, because you know like how I do not need to just repeat this thing again and again, because obviously you know like how much efforts like I'm making to create these videos and how much time I'm devoting to create these videos. You already know these things. I do not need to just say it again and again. So if you really want me to continue creating these videos, and if you really feel that I'm just adding some value to your life and I'm just saving your thousands of bucks, and if you really want to support me, support my channel, so you can simply go to YouTube and simply you can join my channel and you can simply support me, support my hard work, because I'm really doing my best what I can do, and I'm just trying to provide you, let's say, competitive skills, competitive knowledge that is really, really hard to find. And trust me, I have myself like spent so much of time to actually grasp these skills. So if you really, really, really do care about me a little bit, so you can definitely support this channel and support me, and let's become a loyal data family member base. And I'm really, really expecting a lot of love from your side. And just show me some love, just show me some support. That's all I can say, because I don't need to request in front of you, because the bond that we have already created, I don't think so I need to request. So just click on this join button and just support this channel in any way that you can. So let's start the video now. Actually, let's get started. In order to create your free Databricks account, the steps are really, really simple. Trust me, you do not need any configuration at all. So just go to Google and just type Databricks Community Edition. I think I have already typed it. So yeah, this one, just click on it. Then you will simply see Database Community Edition login and sign up. Just go with sign up. Obviously, you can just navigate to this page as well, but it will just directly take you to the desired location. So just click on this. Then you will see your sign up page. I think they have just changed the UI. Earlier it was like sign up page was here, but we do not need to worry. You have Ansh Lamba with you. So just click on try Databricks. Okay. Then it will simply say start a free trial, use Express setup. So quickly get hands-on with Databricks. We will manage your account and cloud infrastructure. Continue with Express setup and use your existing cloud account if you have significant data volume in your cloud account or want. So moral of the story is do not pick these two. By the way, these are good options. By the way, this is a very good option. But the thing is, you will not be able to perform all the stuff, because they will just provide you some amount like $40, and they will just restrict you to just use streaming and all. And the motive of this video is like most of the question will be regarding streaming, because that is the future. So simply just ignore these two options and just look at this tiny option which is hidden, which is called looking for Database Community Edition. Click here. So you just need to click here. That's it. So when you will be clicking on this, now you will be actually landing on the community edition. The other one was the free trial, that was the community edition. So you can simply click on this and you can simply put your email ID here. And once you put your email ID, simply click on continue with the email. Then after just providing the OTP, solving so many puzzles, you will actually land on this particular Database Community Edition homepage. Sorted. So as you know, this is the Community Edition. So obviously, if you want to upgrade it, you can upgrade it, but we do not want to upgrade it. And don't worry, I have just designed all the scenarios in such a way that you will learn everything without upgrading anything. So think you can just say thank you. Thank you to me. No, just kidding. So without wasting any time, let me just tell you what is our scenario number one. So you have the first scenario, and the scenario is the most common one. And if you are applying for like data engineering jobs, and even if you are placed as a data engineer, this is the scenario that you will be tackling either in your interviews or in your day-to-day tasks. The scenario is you have a data lake. Obviously we work with data lakes, okay, in which the pipelines will ingest the data frequently. Makes sense? You means you as a data engineer need to process the file as soon as they arrive in the data lake. So let me just visualize this particular scenario so that you can understand. So let's say you have a source, okay, you have a source and you have your data lake, okay. Now you have a pipeline. Let's say this is your pipeline in the middle. It can be your Databricks pipeline, it can be your Azure Data Factory pipeline, it can be like any pipeline, okay. So this is just reading the data from here and it is just pushing the data here in the data lake. Let's say this is your file number one, and after some time they threw you another file. So now you're reading this file. Then when you just read these two files, then you will be having a new file. So you need to just read these files as soon as they arrive. So one thing was hidden in this particular scenario, but that you can actually understand when you actually know how to deal with these kinds of scenarios. So you need to follow the concept called idempotency which is also popular as with another name which is called exactly once. Okay, exactly once. So what does it mean? So that means if you have like this file, okay, if you have already read this file, you should not read this file again. No, you will only include this file in your next data processing. That's it. Then you will only include this particular file in your next data processing. That's it. Then you will not include this as well. So this is called idempotency, exactly once. And you need to just do this. How you will just do it, let me just show you how you can just do it. And there's a one simple hint. The hint is we will be using autoloader. And even before applying the concept of autoloader, you should know how it works. Then only you can just tackle the subsequent scenarios that you will be just looking here. So let's see how we can just do it in Databricks. Let's see. First of all, what we will be doing, you have already seen the scenario. So in order to work with the scenario, we first need to upload the data. Okay. And another thing, do not worry about the data files that I will be using here, because I will provide all the files, everything in my GitHub repository. You can go and just download those files from there and just relax. Okay. So first of all, I will simply go to catalog. Okay. Then it is saying, hey, you need a cluster, create a cluster to access tables. Bro, we do not need to access this. So simply click on dbfs. Okay, do not click on tables because we are not creating a table. So simply click on Databricks file system, dbfs. So here we have already pre-built folders: file store, local disk, user. Simply click on file store. Okay, don't worry, I already have few folders because I was just using Databricks let's say few weeks ago, like this Databricks community edition. So do not need to worry. Oh my god, Ansh, you need a haircut. I know, man, I know. So just don't focus much on my hair. Okay, so I just have three folders. In your particular scenario, maybe you will just see this one, tables. That's it. Okay, so do not worry. And by the way, we will be creating new folders, so do not feel sad. So in order to create new folders, what you need to do, simply click on upload button. Okay, first go to file store, do not select any folder, and then simply directly click on upload. Then I have optional button here, so whatever I'll be typing here will be treated as a new folder. So let's say I want to create a folder called uh, raw source. Okay, let's say this is my folder. Okay, and just remember to add the slash. Then I just need to click on this drop files to upload or click to browse. So when I will, oh, I just clicked on escape button. So simply click on this, then raw source. Okay, then click on this. So as you can see, I have selected this file. It's called sales data first, which will be our first file that will be coming through pipeline, or let's say you can say like it will be the first file that will be ingested. Okay, simply click on done. And by the way, this is the location that you can copy from here in order to save your time. Just click on done. Perfect. As you can see, this is my raw source and I have this file. Perfect. Simply go to workspace, and when you will be going to workspace, these are like my previous workspaces, so ignore it. I will simply create a new one. So pick folder, and this time I will simply say PySpark and then real time. Okay, create, and then within this I will create a notebook. Perfect. First of all, just connect your notebook with a cluster. Currently I don't have, so I will simply say create new resource, create, attach and run, and this is my runtime. As you can see, 12.2.2 LTS. So simply click on this. LTS is for long-term support, if you don't know. This will take few minutes to trigger this cluster, to actually create the cluster. Okay, meanwhile I will simply rename my notebook. Perfect. So I can simply say Autoloader. Perfect. So now, as you know, that we will be working with Autoloader in order to process our data incrementally, right? But let me tell you one thing, bro. You need to understand the whole working, the whole architecture of Autoloader, like how it works and how it actually reads the new file and how it will actually do everything. Okay. So in order to do that, meanwhile, this cluster is like revolving. So we can just wait and I can utilize this time, and I will definitely tell you what is the architecture, because I want. So basically there are like two things. One thing is I can simply write the code, tuck, 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 that's it, and I will say, hey, this is your solution. I know this is the kind of solution that you are seeing everywhere, but here on this channel, what you will get? End-to-end knowledge, bro. End-to-end knowledge. So now I will just tell you what exactly happens when we use Autoloader and how actually it works behind the scenes. Okay, so let's actually discuss about the Autoloader in detail, and after this you will master this architecture, bro. You will know everything you need to know in the world of Autoloader after this. Okay, let's start. By the way, our cluster is on, but still I will just tell you because I promised. Okay, and just drop a comment if you will understand all the things in this autoloader topic that I'm just going to tell. Okay, you will just say it was helpful if you will understand everything. Promise? Okay, because I'm just making these extra offers just for you so that you can understand. Okay, so the scenario is, it's very simple, because that is the nature of our channel. We just make complex things much simpler. Okay, so this is your source. Okay, this is your source. Okay, this is your destination where you need to put the data. Simple. Perfect. This is your autoloader, which is just doing all the things. Okay, perfect. Let me just write AL, not Ansh Lamba, it's autoloader. So let's say we have one file, right? We have one file. We have just like just uploaded one CSV file. So we know that we have one CSV file. Makes sense. So now what autoloader will be doing, what exactly it will be doing? By the way, before even starting anything, Autoloader detects the files in the source using two methods. Using two methods. Method number one is file notifications. Okay. Second method is API calls. So when we say file notifications, we mean to say that if you're using Azure, it can use storage events. It uses storage events if you're using Azure. Or you can say it is similar to that concept. When new file arrives, it will get to know, and then it will just trigger the process. This is one way of doing it. What we use and what most of the people use in the industry, it is API calls. Because in this, you do not need to configure storage events. Yes, in the real world, you may need to configure storage events if you are using Azure, and if you're using AWS or GCP, you would do the same thing with S3 buckets and all. So every subscription does not hold that particular capability to actually work with storage events. Okay, we can configure it, not a big deal, but still I'm just telling you. So that is why in the industry as well we use API calls. Okay, sorted. So this is one part of it. So we will be using API calls. Okay, understood? Okay, so now what will happen? This is our new file. Okay, this file is here. Autoloader will know, okay, we have this file here. Okay, what it will do after this? It will read this file. Okay, after it will read this file. Oops, man, just create this. Okay, it will read this file. Then it will create one folder, one special folder, which is called schema location. Repeat it with me, schema location. Okay, this is a particular folder which it will use to store the schema of the file, schema of this CSV file. It will write the schema. Let me just create that particular thing so that you can just know, okay, this is the schema of one file. Perfect. Okay, then it will simply write this data here. Okay, and it will simply push this data. Perfect. Now new file will arrive after, let's say, few seconds, after, let's say, 20 seconds, 30 seconds, or let's say 5 seconds. Autoloader will detect the new file using API calls, and here is the thing, how it will know that new file is arrived and it just needs to read this file only, because it will not read this file this time, it will only read this file. How it will know? Because because now is that particular important part. So before writing this data to destination, okay, or let's say while writing the data to the destination, it maintains one more folder. It's called checkpoint location. Okay, checkpoint location. Now, why I have created checkpoint location on top of schema location? You can keep both the folders in different locations, but it is a good practice that we just keep schema location within the checkpoint location so that we do not need to manage two different folders, right? Make sense? Okay, perfect. So within this checkpoint location, we will be having something called as a folder which will be named as rocksdb. Rocksdb will be holding your all the metadata of the source files, and by which it will know, hey, this file is right, hey, we just need to read this file, hey, we just need to process this file, not the previous one. So this is that particular folder. Don't worry, I will just show you everything practically as well. This is the architecture. Now when it will be just reading second file, it will again, if schema is changed, if schema is not changed, nothing will happen. It will simply go and it will update this file. Which is the file? Like, what is the file? Schema location file. Okay, like schema within the schema location. Perfect. Got it. So it will just update that particular file. That's it. If schema is not changed, then obviously file will be updated, but you will not see like any changes because it is exactly the same, right? Perfect. Once it has updated the schema, then it will just process and push this data to the destination. This is the architecture. Okay, and I hope now you have understood the architecture, and now we will be seeing like how we can just do it practically, and let's see how we can do it. So it is very simple. First of all, we will read our data just to show you like how data looks like. So df equals spark dot read dot format is csv. Okay, then dot option, then I think header, yeah, header true because it is a csv file. So dot option, then we can simply say infer schema. Okay, infer schema true, then dot load, and here we can just simply paste our location. Let me simply say df dot display. Let me just run this. So whenever we run our first command, it takes some time, but after then it will just run smoothly, so do not need to worry at all. So let me just collapse this, or let's wait. Let me just show you the data. Okay, so by the way, this is your data and it has successfully inferred the schema. As you can see, 1 2 3 1 2 3. Okay, perfect. Now I want to incrementally read this data. Now we will be actually processing our autoloader query. So in order to do that, let me just create a markdown, and let me just simply say autoloader, and now we will simply say df equals df spark dot read. This time, instead of saying read, we will be saying read stream, because we will be using streaming API. Okay, so read stream dot format. Now what is the format? CSV? Not really. The format in autoloader is always cloud files. Perfect. Then we will define what type of format within cloud files. Now we will say, hey, CSV. So dot option cloud files dot format equals to CSV. Make sense? Very good. Now, as we just mentioned that we need to also store our schema somewhere. Okay, so where we'll be storing our schema? Let me just tell you. Dot option cloud files dot schema location, and this will be our not this particular folder. We will create a new folder within file store and we will simply say destination. Okay, and I will simply pick as raw destination because raw source, raw destination, so it makes sense. And within this folder I will create another folder called checkpoint. Oops, checkpoint. Perfect. Then I can simply say dot start. Okay, and then I just need not dot start, dot load. Then I can simply say my location, and my location is source, row source, because I have not created any kind of folder within this, within raw source. Okay, makes sense. Very good. So I will simply click on this and it will just run this query. So now you will see, hey, nothing actually happened. Yes, nothing actually happened. The reason is lazy evaluation. Lazy evaluation in Spark. So whenever we will be hitting an action, only then it will just perform that particular task or transformation. So let's actually write this data, this streaming data. Okay, so I'll simply say df.write stream. Okay, dot format. In which format I need to write the data? I want to write the data in delta format. Okay, let's see delta. Then dot option. Now I'll simply define the checkpoint location. Checkpoint location. Then I will simply pick the location with called raw destination, and within this I will create a folder called data. Perfect. Then I will simply pick dot option, and I think I have nothing to pick much in dot option, but yeah, one thing I need to pick dot trigger. So after how much time I need to just process my data? Let's say 5 seconds, let's say 3 seconds. Okay, so I'll simply say processing time equals to 3 seconds. Perfect. So it will just check the query in every 3 seconds, like what is the progress and what is happening. Okay, so then I will simply say dot start, and then I will simply define the location, and location is this one, raw destination data. Okay, and let's give another destination here called checkpoint because we need to just create checkpoint. So just change it. Okay, now it is all set. Now when I'll be just hitting, like when I'll be just running this cell, you will see query will be initiated. See, streaming initialization. So now your streaming query is initialized. Let me just click on this drop down. You will actually see the graph in the real time. Data will be coming and it will be reading the data and you will see the graph. Just hold on. Just hold on. So now see, now you can see input rate 48.8 record per second and processing time is 5.5 record per second, as you can see, right? And this is the graph that you can just analyze. Now why it just went down? Because we do not have any much data. One thing to note more, as we just mentioned the real-time scenario, like data will be coming in continuation. So what? This pipeline, this particular cell will be running. See, it will be keep on checking after every 3 seconds, like do we have the data, do we have the data, do we have the data? If no, nothing will happen, bro. Now I will show you something. What's that? Now I will upload one more file in the same location and you will see this graph will go up again and it will just read or process the updated records, only updated records and only updated files. And just to verify that, I can also run one more cell just to validate that information. So simply say select asterisk from delta dot ticks. By the way, this is not the single quote, this is tick, which is available like the button just towards left of number 1 and just above the tab key. So delta dot that particular location, raw destination, or let's say, let me just pick the whole location from here because this is our destination for the data. So if you will just query this, if you will just query this data, then you will see, I think 90 something records, if I'm not wrong. Yeah, 95. So now in the second file that I'm going to upload, it has, I think, 30 something records. So total records will be 95 plus 30 something, maybe like I don't remember the exact number, but like it is closer to 30. You will only see like 30 plus records will be added to this one. Okay, just go to catalog. Okay, and then just go to workspace, or simply go to catalog from here, and then you will simply see dbfs. Simply go to raw destination, simply go to data, and then you will see, hey, your file is there. This is your delta table, or let's say delta file. Okay, now what I will do, I will upload one more file in the raw source. Simply click on upload. So I have uploaded my second file here as well. See, now the moment I will click on done, it will just process that as well. Let me just click on close, close. Let me just show you. See, see, it automatically went up. It automatically went up because my query is running. This is called streaming. Okay, this is called streaming. Very, very, very well done. Very well done. See, it just processed or read just 30 something records. And when I just query this data again, you will see 120 something records. Yeah, 126. See, so it has just automatically read your data. Automatically read your data. Okay, perfect. So now I will, like, obviously our first scenario is completed, but I want to just show you something else so that you can just learn. Simply click on dbfs, then simply go to your raw destination, and then just click on this checkpoint. Within this we have like so many columns. Okay, so many columns. By the way, we have offsets, and within this we have, I think, commits as well. Yeah, within this we have sources, then we have something called as schemas. So within the schemas, this is our basically the schema location that you were talking about. This is the one that you were talking about, like, hey, this is the schema location, and this will just store the schema in this one. So if you just simply click on this, this is the API format. It will not allow us to read it. We can obviously download it and copy the path. If you want to read it, we can just simply query it. And within this we have these folders like such as commits, offsets, and these are the files that are stored here. So within these folders we have this particular folder called sources. When you just click on it, you will see 0. Okay, just click on this for one more time. This is your folder that I was talking about, rocksdb. So this folder is responsible for your new file listings, like whenever new file is coming, and it will just read that particular file. So this is the folder rocksdb within the sources, within this 0 folder. Okay, and schemas I have already shown. So now what I will do, I will just take you to the next scenario, which is directly linked to this one, and that will just level up your knowledge of Autoloader. Let me just show you what's that. So the next scenario is, I know it is very similar, that's why I told you, but the concepts wise, it is very, very complex. Okay, so you have a data lake in which pipelines will ingest the data, but this time with new schema. Let's say you are just uploading files, and obviously we just uploaded the files, but this time it is just, who is this man? So this time it will be just uploading the schema like with new columns. So file will have new schema. Wow, how we can just handle that? Let me just show you what will happen if you upload any file with the new schema. Let me just show you. Okay, and don't worry, you will know everything, like why it is failing and how we can just work with it, because obviously in the real world we work with files which have like different schemas. That is the era of big data, right? That is why we need data engineers. That is why company needs you. So now just learn this, how you can just tackle this. So let me just show you. We are in our database workspace, and you can see that it is feeling lonely, that it doesn't have any files, but we will provide the new file. So let me just show you when I'll be just uploading the file and what will exactly happen. So I will simply say catalog, and then I will simply go to dbfs, file store, then raw source. Okay, because we are just running streaming on this particular folder. Let me just upload the third file, because in the third file we have a new column. It is called return flag, which is not available in these two files. Okay, let me just pick this file. So this is my third file. Okay, sorted. Let me just click on done. So you will see it will break. Let's wait. See, it broke. Why it broke? So just read the error. Unknown unknown field exception. That means it is saying, hey, what is this return flag in CSV? We do not have that. We do not have that. So what is the solution for this? What is the solution for this? Let me just tell you what exactly happened. and how to just tackle with this scenario. Because let me just take you to the documentation page first of all. So it is saying how does autoloader schema evolution work. Okay, so now you already know the architecture. Let me just give you a brief like what exactly happened in this particular scenario. Okay, then I will just come again on this page. So let me just show you what exactly happened. So this was your source. Okay, this was your destination, and these were the two files, and this was the schema location. By the way, bro, no one will tell you the actual reason behind this, so just be focused. Okay, so this was the schema that was written here for both the files because schema was same. Okay, then new file arrived and it had one new column. So what autoloader did, it just wrote back this particular schema to this file, and it just added this particular column at the end. Yes, it adds the new columns at the end. So this is my new schema. Okay, this is my new schema. Very good. Now you will say when it will write this data, this one, okay, why it actually failed? Why it actually failed? Because this autoloader, just listen to me carefully. Just listen to me carefully. This autoloader inferred the schema for new file and saved it here. Makes sense? Okay, and saved it here. Then why at the time of writing it failed? Why? Why? Now some of you will say, hey, because schema of the destination is not same with the schema of source. No, no, that is the second step. It actually failed before that. Don't worry, I'll just validate everything whatever I'm saying right now. So it actually failed before that. But why? So I also like spent so much of time to actually find the issue when I was learning this. So the issue is, so the thing is, when this autoloader works, okay, when this autoloader works, it first reads the first file, common sense. It infers the schema for this file, common sense. Then it caches the schema into its memory. It caches the schema. Yes, it caches the schema. Okay, and then it will just write the schema in the physical file. Sorted. Then when it writes the data here, let me just draw it with green. When it writes the data here, it matches this schema with this schema, and then it writes it to the destination. But at the time of third file, it updated the schema here, but it did not update its particular cached schema. Yes, it does not every time updates its cached schema. That is the reason. So what happened when it was about to write this data to the destination? When it was about to write this data to the destination, it said, hey, your schema and your schema is not matching. So we again need to reinitialize our query. Then it will restart or refresh its cached schema, and it will just take this new schema and cache it to the memory. Sorted. This actually happened. This actually happened. And let me just show you, let me just validate my points, because a lot of you will say, hey, no, blah, blah, blah. So wait, hold on. I just talk facts. Okay. So it is saying autoloader detects the addition of new column. Okay. And as it processes your data, when autoloader detects a new column, yes, the stream stops with an unknown field exception we have already seen before your stream throws this error. That means it actually didn't throw the error. First, it performs the schema inference on the latest micro batch, that is your latest CSV file, and updates the schema location with the latest schema. That means before actually throwing the error, our schema location was updated. That means it successfully inferred the new schema and added the columns there. Right? Right? Very good. So this actually happened. Now, in order to work with this thing, one simple thing is we just need to restart our read stream query. So now when we will be restarting this, it will run fine. Not exactly. Now that point comes into the picture, that now when we just ran this, now our source schema is fine. Our source schema is merged, okay, with new schema and the CAD schema. It is merged. Perfect. Okay. Now we need to merge the schema of the destination as well, because in the destination, in the delta log, we do not have that particular column. So we will simply write here dot option. Okay. Then I will simply write merge schema equals true. Okay. Very good. Now when I will just run this, it will run fine. And if I do not write this, it will still throw the error. Let me just show you. Let me just remove this for you. Okay. Let me just remove this and let me just run this. It will just throw the error. And the error is, see, a schema mismatch detect when the writing the table to this destination. Then we can simply write this thing that we just removed. Okay. Now it will run fine. So actually there were two issues. It is not just about like schema mismatch on the sync side. No, that is the second step. The first step is merging the schema in the source side. So now as you can see, our query is running absolutely fine. And you will see our graph very soon. Perfect. Now if I just query this data, I will see, I think 226 records or 225 records, because I have 100 records. Yeah, I have 100 records in the third file. So perfect. And let me just tell you what is not, what is like actually hidden here, but actually what we are writing here. So the thing is, whenever we want to just process new columns, we write something called as dot option cloud files dot schema evolution mode. This is the thing that we write, and by default it is add new columns. I can just show you here as well. See, this is the schema evolution mode, and this is the code that we write, schema evolution mode, and by default it is add new columns. So even if we are writing it like this, it is fine. Even if we are not writing it, it is still there, but it is just not visible to you. Okay, very good. So now if you just see the query results, you will see one column is added, which is this return flag. Okay, now one thing for you, extra bonus. What is this rescued data? What is this rescued data? So the thing is, we have one more special evolution mode. By the way, we have total 4 modes, but we use just 2. So this is already done. What is this rescue? So the thing is, let's say we have 2 more columns. Let's say we have 3 more columns. So every time we will be just doing it again and again, and we will just merging our schema with the destination, and we do not want to do that. So what we can use rescue. And when we use rescue, it will create a column in which it will store all the data in the form of dictionaries, in the form of key value pairs. So it will just say, hey, this is the column, this is the value, this is the column, this is the value. So in that particular scenario, you do not need to write this merge schema. Why? Because rescued data column is already there. And this is the another validation point, that whenever our query fails, it fails because of source side, not on the destination side. Not on the destination side. No. If someone is saying that it fails due to that particular reason, no. No. So now you know the actual reason. Now you know why it failed, right? Okay. Very good. I wanted to discuss this thing in detail. So now you know actually what I wanted to discuss, because I have already discussed. I hope that now you can just tackle any scenarios in the world of autoloader. And yes, autoloader we use in most of the times, and we use it with Databricks a lot. So it's a good thing to know. Okay. So now let's see what is our next particular real-time scenario that we'll be looking in this particular video. Let's see. So our next scenario is really special, because that is directly linked to your data warehousing, and that is directly linked to your like next level knowledge that is required to handle this, because there are like so many parts that are combined within this particular solution. So the solution, like not solution, like scenario. So the scenario is, it says implement a solution to handle slowly changing dimension, okay, for both initial and incremental run in one notebook. So if you know the complexity of handle initial run and incremental run for slowly changing dimension within one notebook, you would know like how complex it is. And if you do not know, I'm just telling you, it is a chaos. Because the thing is, it is not difficult to manage a slowly changing dimension, but when we deploy that particular notebook, we need to create our notebook in such a way so that it can easily handle the initial run and incremental run. What is initial run and incremental run in this case? It is not incremental loading. It is something different, but yeah, it is linked to that thing. So let me just tell you. So let's say we have one table. Okay. Okay. So let's say we have ID and we have name. Okay. This is 1, 2, 3. So this particular name, like it can be anything. So when we will be just pushing this data here, it will just take all the surrogate keys, right? Easily. Like it can just do these things easily without any issue. Okay. Like 1, 2, 3. But when we will be having new set of data, let's say in the new set, we have, so this is the new set. Okay. This one, let's say we have IDs such as 1. Okay. This is ID column 1 and 4, let's say. So now you will say we cannot insert this data because we cannot have duplicates in dimension table. Okay. We cannot override this table because obviously otherwise these records will be removed. So we use something called as update plus insert, and that is also known as slowly changing dimension type 1. That is the one complex thing. Second complex thing is managing this whole notebook within the, like managing the whole solution including initial run and incremental run within the single notebook. That is the important part. But don't worry, we'll be using our Python for it, and that is why this particular scenario will test your conditional statement within Python. I'm not testing your knowledge, so you will be using, yeah, like if condition, else condition, will be using a proper solution using Python. Okay, let's see how we can just do it. So oops, so first of all, oh, by the way, this is still running because this is a streaming. So it is just waiting for the files and we do not have anything. So just click on interrupt. Otherwise it will be just spinning your cluster. And obviously it is expensive. This is free, but still I'm just telling you so that you can just become an efficient data engineer. You should know about the cost as well. Okay, so now this is stopped. Now let's create another notebook. Let's go to workspace and let's create, oh, where is that particular notebook? Oh, I think it is inside this. Yeah. Let me click on create notebook and then I will simply name it as slowly changing dimension. Okay. Obviously connect this with the cluster. So I will simply create the markdown. I will simply say slowly changing dimension, initial and incremental both. Perfect. Whoa, this is huge. Okay, let me just remove this. Let me just run this. Okay, perfect. Slowly changing dimension, incremental and initial. Okay. So the thing is, for this, obviously we need a CSV file, or let's say we need a table, we need a source table, right? Obviously we need a source table, right? We need a source table. So how we can just do this thing when we have like, we can just deal with this using CSV file as well, not a big deal. So what we will do, I will simply go to catalog and then I will simply click on DBFS. Okay. Then I will simply slide this and simply go to file store. Within your file store, I will click on upload and I will create a new folder. And this time I'll simply say raw CSV. Okay. Simply click on done. So where is that folder? Raw CSV. Simply click on file store and oh, we didn't upload anything. Okay. Raw CSV. Okay. So this is my raw CSV. Perfect. Now I'll simply pick that file. So this is my file, products dim table. Let me just click on done. So as you can see, this is my file, productdim.csv, productsdim table.csv. Okay, so this is my file. Simply click on close, and then I will simply read this data. df equals spark dot read dot format csv, then dot option header true. Whenever you are using csv, always make header true because csv files do not have any schema, so it just treats your first line as header. Then dot option infer schema true. Very good. Dot load. What is the location? What is the location? I think it is files underscore, I think raw csv. Yeah, I think so. Yeah, let's try it. If we see any errors, we can just correct the location, no worries. Yeah, path does not exist. I think it is, just go to file store, raw csv. Oh, file store is in, okay, by the way, I have the location, no worries. Let me just copy it here. Perfect. Let me just run this. Perfect. So in order to view the data, let me just show you first. Okay, let me just show you. So this is your data. Oh, having 31 rows. Oh, why we have like so many null columns? Okay, so when I was just creating the CSV, so maybe I just clicked on these cells and it has created this one. So I don't want this. I can simply apply some transformations. Simple. So I will simply say df equals df dot select, and I simply need PID. Okay, then I need P name, then I need P category, that is product. Then I will simply say dot filter. Okay, dot filter, and then column is PID, dot is not null. Perfect. But in order to run this, we need to import some libraries. So I will simply say from PySpark dot SQL dot functions, import asterisk from PySpark dot SQL dot types, import asterisk. Perfect. Let me just run this. Perfect. Let me just run this as well. Perfect. Now let me just click on df.display. Okay, perfect. That's what I want. Sorted, clean and sorted. So this is our dim products. Okay, this is the primary key, or let's say business key. Okay, so this is the key which we need to use when we will be just applying absurd logic. Okay, so what we will be doing, this is our new data. Makes sense? This is our new data. Okay, makes sense. This is our data that will be coming every time, right? Let's say for this time we have just 6 records. Let's say second time we have 6 more records with some changes in the primary key and with new additions as well. That is the definition of slowly changing dimension. So you should have your fundamentals clear in your head, that like what is the slowly changing dimension. Don't worry, I'll just tell you. So this is our dimension. So what I need to do, I need to simply write this data to a table, to a delta table, and I need to write this in such a way. Let me just tell you what do I mean, because I know it is really complex, but I'll just make it simpler. So df dot write dot format. Okay, this time I want to save the data in delta. I love delta. Then I will simply say dot mode append. Okay, dot option. Then I will simply say path, and path will be this one. No, we will create a new folder inside this. We will simply say raw csv sync. Perfect. Okay, then I will simply say dot save as table. Okay, perfect. I can name it as anything. Let's say I want to name it like product stem. Makes sense? Yeah, I can run this. But I will not run this because it will throw some errors. Not this time, but in the next iteration. Because let's say I run this cell, output will be simple. It will create the table. It will create the dimension table. Okay. Now let's say I upload another file next time. Okay. Then it will just read this data again, obviously. Okay. Then it will be having maybe same records or maybe different records. We do not need to care because that is the definition of slowly changing dimension. So even if we have like same records or different records, we should not add those records. But if I will be running this cell again and again, it will simply append the data. It will simply append the data. It will not actually upsert the data. Okay, very good. Okay, so now is the thing. What we will be doing? We will apply a logic called upsert, and it is called merge statement. So in order to do that, we simply need to import one more library. It is called from PySpark dot SQL dot delta table. I think PySpark dot delta tables. Oops. I think dot SQL will be there. Yep. Yep. Delta table. Import delta tables, like delta table. I don't know if it is table or tables. Let's see. I think it is tables. Yeah. Let me just add s here. Oops. PySpark dot SQL dot delta tables, or I think let me just try this one from delta dot tables. Import delta table. I hope it should work. Yeah, finally. So this was the library, and we imported this particular module called delta table. So now we will be, what we'll be doing. So just imagine that this command is already completed. Just imagine. You will get to know why it is completed, because we will just complete the solution very soon. So if this command is completed, so what we will do, we will simply create an object on top of this table, which will be our delta table. Okay, so I'll simply say delta table. This is a variable, you can just pick any variable, equals to delta table, oops, dot for path. Now I have two options, for name and for path. I can just pick any one. I personally like using for path, because even if we have table, we can use for path. Even if we do not have any table, it still works, so it is fine. Dot for path. Then we need to define Spark. Then we need to just define the location where it is stored. So that it is stored in here at this location. Perfect. So what it will do, it will simply create the delta table object on top of this data. Once it is done, we will apply a logic called merge. So delta table dot merge, and we will just merge it with df. We will merge it with df, which is our new table. So in order to mitigate any kind of confusion, so we will simply use alias. We will simply use alias as target, because this is our target and this is our source. Okay, even if it is not clear right now, don't worry, just rewatch this part once it is completed, because I know this is complex. That's why it is called real-time scenarios. These are complex. These are complex, and these should be complex. That's how you learn, right? This is not the video where we'll be discussing only simple solutions. No, no. So once it is done, now we need to just provide the condition, like the joining condition. So the joining condition will be target dot PID, which is our primary key, equals to src.id. Once it is done, once it is there, simply I go to next line. First of all, once it is done, I will simply say when matched, or yeah, so it is not recommending me, I have to write the whole thing. So when matched, then update all. Okay, when not matched, then insert all. These are the two functions that we use, and then we need to just execute it. So we simply say execute. Oops, execute. Okay, simple. This is the code. Let me just show you in the documentation as well. So this was documentation for Autoloader. Let me just see scd Databricks. Okay, let me just see if it is the one. Oh, this is a blog. Upsert, or let's say merge in Databricks. So merge into Databricks. Yes, this is the one. So this is obviously the SQL code, and we personally like using Python. So I'll simply look for Python, and this is also SQL. This is also SQL. Where is the Python, bro? Where is the Python? I think this is the one. Yeah, this is the one. So when you just go to the Python, you will simply see I have just written this thing, when matched update, but I have used update all. That saves our time, because we know that we need to update all the other columns other than the primary key If you just want to update specific columns, you can simply use set. And set, you just need to just define the schema, like key in the key value pairs, and obviously you need to just define the dictionary that you need to just update these columns, and you can simply say update, then go inside the braces and set equals dictionary. That's it. Then insert, same thing, but personally I use insert all, because in most of the scenarios you'll be just inserting all the data. You will not be the one who will like to lose the data. Okay, so this is a syntax that I wanted to discuss with you, and I just wanted to just show it to you. So now I will simply run this. What will happen if I run this? It will obviously throw the error, because it doesn't know. These are basically two different blocks of code. If you do not know, if you haven't observed, so these are two different types of blocks of code that we need to run within the same notebook. And what will be the scenario? Just tell me in the comments. What will be the scenario when we'll be using this one and we'll be using this one? Just tell me. So if we are running our pipeline, or let's say if we are running our notebook for slowly changing dimension for the first time, that means we haven't any kind of table for dimension, it is new. Then we will first create that table, right? But when we have that particular table, created, we will be using this particular command. Got it? Then we will be using this particular command, and otherwise we will be using this one. Make sense? Okay. And how we can just handle this scenario with this one? So we can simply create something called as variable. Okay, so let me just type db dot widgets dot text. Okay, and I will simply call it as initial load or initial run. Okay, and I will simply give the default value as 0, let's say. Okay, let me just run this cell. What? db dot widget dot error, db dot widget. What is the issue, man? db dot widget dot, maybe it is not allowing us to use widgets in the community edition, maybe, but still we do not care, because we can simply define the variables here. So we can simply say initial run, because otherwise obviously we would need to just fetch the data using db dot widgets dot get. So obviously at the end we will be using, like, saving the data variable in the particular parameter. So initial run equals to 0. Okay, perfect. Let me just run this, or let's say 1, because we do not have any kind of data. So we just have initial run equals to 1. Very good. So now what I will do, I will simply add a statement called if. So if my initial run equals to 1, that run this cell. If it is not equals to 1, then just run this cell. So now it is sorted. So now in the real world, what you will do, you will create the parameter here, and you will see the widget here that you can just feed from ADF or maybe anywhere else. That is not the thing, that is not the big thing. You can just obviously feed the parameter. Big thing is this one, using this variable smartly here. So in your first run, you will just pass the parameter as 1. When you will just deploy your notebook, let me just run this. What will happen? You already know. What? Wait. It is 0. Okay, now we can run, because obviously this is second run. It is not initial run. Initial run is this one. So just a quick fix. So now it is running. Now it is creating your table. This table. Why? Because initial run is 1. Perfect. It has run successfully. Very good. Let me just show you the result. Select asterisk from this table. And what is the table name? I think products dim. Yeah. Let me just run this. You will see just 6 records. Very good. Now, once this code is deployed, I will change this parameter to 0. Obviously, now if I am just reusing same notebook, this will not break. No, this will not break. Why? Because when I'll be running this, let me just run this. So what will happen? See, it ran successfully. Let me just rerun this. What? What? Why it inserted the data? Let me just check. Wait. Target dot. Oh, my bad. I was like, why? So I didn't write the column name as it is. So what I was expecting. So now you know. By the way, it is good if we have seen the error, because now you know the scenario, what exactly should happen. So I was expecting only these 6 records, because I want to update these records, because these are not new records. But I by mistakenly just added these records here. Okay. So not a big deal. What we can do, we can simply drop this table first. So drop table product stem. Perfect. Let me just drop this table. Okay, perfect. Let me just delete the cell, and let me just again run my initial cell as 1. Perfect. Very good. So what we'll be doing, I will simply run this cell. Okay, and now you know which cell will be running. Obviously this one. What do you need? Oh, I got it. I got it. I got it. So it is saying it is not empty, obviously, because when we just drop the table using the delta table, so it does not actually deletes the data. Okay. So in order to do that, we can physically delete the data, or the second way is simply change the location 2 and 2. Sorted. Just say 2. Okay. You should know how to debug your code. So just run this cell, and this time you should see just 6 records. Let me just run this cell for one more time by putting 0 here. Just run this, and just run this cell for one more time, and when matched, then update all. Is spelling correct? Is spelling correct? When update. Oh, we do not need to write then. Okay, just remove then. Just remove then. Perfect. Just run this. So perfect. So let me just run this, and this time we should just see 6 records. That's what I am expecting this time. Okay, perfect. Perfect. See, now we just have 6 records. What does it mean? It didn't actually added the records for those records who are already, like, which are already there. Makes sense? Makes sense? So now it will only add new records, and it will update all the previous records. So currently it has updated all these 2 columns, but obviously you cannot figure it out because the result is same, but actually it has updated the data. That's what we have written here. See, when matched, update all. That means if id is matching, update all the columns. Make sense? Make sense? Very good. I know that you have learned a lot. I know. Slowly changing dimension is a broad topic. Obviously it requires lots of experience as well, so do not need to worry. Just rewatch this part if you haven't understood like all the things, but I know you have understood 90% of the things. So just for that 10%, you can just rewatch this part. Okay, so now let's see our next scenario. So this question is really special. Trust me, this is my personal favorite out of all the questions. Like one of the favorite questions at least. Like this is amazing. This is amazing because the question, or let's say scenario, says create a class. So it has just asked you to just implement the OOP concepts of Python, directly the OOP concepts, object oriented programming in Python. Okay, that's why it is PySpark. So you should not expect, hey, we do not need to just learn Python in detail. No, bro, you need to know. So it is saying that create a class to call window functions. Wow. Okay. Whenever needed. Okay. And the best part is on any data frame. That means data frame cannot be static. Cannot be static. Did you understand the concept? What exactly we need to do? Let me just explain you and just take you to the Databricks notebook. This is like one of the favorite questions for today. Trust me, like amazing real-time scenario. Amazing. Let me just tell you. So this is our notebook, okay, and we already have data here in raw CSV. And I will use data from raw source. That will be better. Okay, from the raw source, yeah, we can just use that data, or I will just simply use this particular file, like specific file, so that you can just know like what exactly we need to do. Okay, because we will be creating multiple data frames, so you will know what exactly we need to do. Okay, so let's see what is actually the scenario. And before that, let me just create the workspace and then create a notebook. First of all, let me just connect my notebook to the cluster, and let me just rename it, and let me just call as class. Don't worry, I will just provide all the notebooks. So that doesn't mean that you will not focus here, bro. These are the concepts that you should know. Okay, so first of all, I will simply read the data quickly. Df equals spark.read.format. Okay, formcat format, and format is CSV. Perfect. And I will simply say df1. Okay, or let's say df. It's fine. It's fine. Df equals to spark.read.format, then obviously dot option, and then we'll simply say header true. Then I'll simply say dot option infer schema true. Then dot option, oops, and then I'll simply say enough options. Let's say dot load. Then file store. Then within that, I think raw source. Within that, I think sales data first. .csv. Let's run and just let's see the errors if we have any. Oh no, no errors. Okay, so let me just display the data. Perfect, 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 perfect. So what I want to do, what I want to do, I want to implement window functions. What are the window functions? We have three popular window functions in the market: rank, dense rank, and row number. And we know that whenever we want to just rank our data, we either use rank, or use dense rank. And row number is just to provide the, let's say, data about duplicates. Okay, so window functions are really important, so we'll be using window functions, we know this. But let's say you will be you are working on a project in which you have to just use or call window functions again and again. Like, let's say you change something, then you just need to see the ranking. Then you change something, then you need to just see the ranking. Like, you are just writing a big notebook. So in that particular scenario, instead of writing that code again and again for your window functions, you need to create one class in which you will create functions that are called methods within the class, so that anytime you want to use window function on any data frame, you should be able to do that. There should nothing be static. Everything should be dynamic. All the things should be parameterized. All the things should be parameterized. So this is the scenario. This is the scenario. I hope you understood the scenario. Let me just tell you each and every step what we'll be doing. Okay, let me just tell you. So let's say I want to create a function, or let's say anything for rank function. First of all, then we can also create for dense rank. Then the same way we can also create for row number. Same things, right? Like, everything is same. And we want to apply the ranking based on, let's say, units sold. I want to see the ranking on units sold. Okay, perfect, makes sense, very good. So if I just want to apply the window function without any class, so it will look like this: df.withColumn, df.withColumn. Okay, then I will simply say, let's say, dense rank. Okay, this is the column name. Then I will simply say, for that, I think I need to just import the library. Yep. So from PySpark.sql.functions import asterisk from PySpark.sql.types. Should I just import types? Yeah, we don't know, like maybe we are just converting some types. So import asterisk, one more important, from PySpark.sql dot I think window. Yeah, window. Import window. Perfect. Let me just run this. Perfect. So I will simply say dense rank, then dot over, then window dot order by, or let's say partition by. So I want to apply partition by on top of, let's say, branch ID. Okay, branch ID and dealer ID both. Let's do this. Let's make it more complex. branch ID and dealer ID. Okay, so partition by branch ID, yeah, branch underscore ID. Okay, and then dealer ID. Perfect. Then I want to say dot order by. Okay, order by will be on, let's say, only on unit sold. Okay, makes sense. Unit sold. Okay, unit sold. Perfect. And obviously it will be in DSC, like maybe in the descending order. So dot DSC. Perfect. So this is my column. Let me just show you dot display how it will look like if we do not have any errors. It is saying dot DESC. Why? Oh, I got it. Maybe we just need to define after this. Yes, let me just run it again. Hey, what's the cannot generate code for expression? I think I have messed up with one braces. I think this is the braces that is being closed. So this is the dense rank over. I think DAC cannot be written outside this. I think this should be like this. What's wrong with this then? Okay, let's remove DAC for now because that is not the intent. I will just correct it. So let's remove it and let's run this. Yep, perfect. So this is, by the way, I have removed DAC. That means it will just show the result in ascending order. So as you can see, we have added one column here called dense rank. See, it is saying 1 1 1 1 1 1 1. All the things are 1 because we have distinguished branch IDs. If we, let's say, pick any other column, let's say model ID, because we have like multiple models, or let's say if we just pick any other column. So, or let's say on month, we can also apply on month. Let's apply on month. Let's apply on month. So this time we will see something else. Yes, hopefully if we have distinguished, or let's say apply only month, then we will see ranking. See, because we have duplicate values for month. Okay, so this is the thing that we need to achieve using class, because we do not want to write this thing, because as you know, it will be a mess if we are just this is just the one df. Okay, this is just one df that we are using. Let's say you applied some transformation on some data frame rows. Let's say you removed some columns, then you are saying, hey, I want to again use, or let's say I again want to create another column on dense rank, then you will be again applying this code. So we just want to eliminate this thing. We need to eliminate this thing. So in order to do that, we will be creating a class. So let me show you how you can just create a class. So just be more focused, because now we are just creating a class. So we will simply say class, and class will be with, let's say, name such as window functions. Okay, window functions. Okay, this is my class. You will also learn Python in this particular part of the video. So class window functions. Now I will create the default attribute of this class. It will be the data frame. It will be data frame. So I will simply say df equals spark dot read. I can just copy the whole code, this one. So this will be my default attribute of this class. That means if I will not pass any parameter of the object of this class to the object of this class, then it will just read this data frame, this one. This is the default one, because it is expecting that you have not applied any changes to your data frame. This is the original data frame that it is using. So by default it is using this one. Don't worry, I have promised that I will create a dynamic solution. So we will just change this df. Don't worry at all. Don't worry at all. So you will see everything. So once we have given this is our default parameter. Now we will be just creating the methods. Methods are nothing but like the functions within the class, and we just call them as instance methods. And one is like static methods, another one is like class method. Do not worry, I'm not teaching Python here, but yeah, I'm just teaching you the implementation of Python in data engineering, specifically in PySpark. Okay, so then I will simply create a function def, and I will simply say it as dense rank, because this will be the function for dense rank. Dense rank func. Okay, Then I will simply use self. Now, if you do not know much about OOP concepts in Python, we have to use self keyword whenever we use, like whenever we create instance functions within the class. It is the mandatory thing, because when we use self, we can access these particular variables or attributes within the class. Okay, very good. So this is self. Okay, then I will simply say df. Now, as I just mentioned, if I want to use class variables, I need to use self. So instead of using self df, I will simply use self.df. I know the level is going high and higher. I told you, bro. I told you I will prepare you for the real time complex scenarios in PySpark. So that time is gone. Hey, how to cast this column? Hey, how to add this column? No, use Python, use OOP concepts to deal with the scenarios, right? So you need to be upskilled with the time. So self df, and then we already know that this will be the code. So I can simply rewrite it, because we just need to write the code for one time. That's it. So self.df dot with column. Perfect. Then column name will be, if, oh, that is also dynamic. Okay, let's make it dynamic. So column name will be provided by the user. So whatever name they want to use. So I will simply create a variable here, or let's say parameter called new column. I will simply say new column. This solution will be pure dynamic, pure parameterized. Trust me, this is my favorite solution for today's video. This is very, very nice. And this is built on the special demand. Everyone was saying, hey, how we can just use Python? How we can just use how we can just prepare for Python for the interviews, for the real-time scenarios, and so many other requests. So this one is for you, bro. Just do it. Just learn it. Okay, so this is the new column. And what will be the function? We already know function will be dense rank. Okay, function will be dense rank and dot over, and then window dot partition by. Now this will also be dynamic. I want to make everything dynamic. Let's see, let's ask the partition column from the users. Part columns, simple, and we will just expect a list of the columns. Okay, then I will also create order columns, ord columns, because I do not want to hard code anything. Everything will be parameterized. So window dot partition by, and columns will be your part columns. Okay, part columns. Perfect. Okay, then I will simply say dot order by. Okay, then column of which thing? Orders, like order columns, ord columns. Okay, then I will simply say dot desc, dot order by this one. Yeah, dot desc. Okay, oh, now I got it. What was the issue? I didn't use column in the above code, which was throwing the error. So not a big deal. So this is the order by, and we need to use DSC inside this. Yep, here. Perfect. So this is the code that we will be using. So now what after this? Obviously we need to test it, because I also didn't test it. But first of all, I will simply return my df, because I want to return my df once it is done. So we will simply say return self.df. Okay, perfect. Perfect. This is my one function. So before creating further function, I will simply test this. I'll simply show you how you can just call it and how you can just actually use it. So in order to do this, first of all, I will just reset my df. I will simply run this. Okay, because I don't want to create that column. Now I do not have that dense rank function. See this one, I don't have this. So in order to call any class, we first need to create the object for it. Let's say I created the object. It's equal to object equals to window functions. So this is my class. Okay, so I have created the object on top of this class. Now I can access all the things using this obj.df. Everything. So let me just run this. Window function is not defined. Oh, because I didn't run this cell. So let me just run this cell. Okay, perfect. Now I can just simply run this. Okay, perfect. Now you can see obj is created. So now let's say you have a df. Okay, we know that we have a default df. We know this. We have a default df. I know this. But let's say your df is something different. Let's say your df is second, sales data second. Let's say this. Okay, let's create this df. Okay, so now your df is different. So how you can just pass a new df to this particular class? So it is very simple. You will simply write obj dot equals to df. Now you will say, hey, I'm getting confused. So your point is right. We can simply say df new. Okay, simply run this. So this is df new. So now you have changed the default parameter or default attribute of this class for your particular object, only, not for the others, only for your particular object. Okay, only for your particular object. So now when I just run this, it will simply change this df with df new. Wow. Then I can simply call this function. Let's say I am writing my code and I want to just apply dense rank function on top of my data frame. Okay, I do not need to write any code. I will simply say obj dot dense rank function, and I will simply pass the parameters. And what are the parameters? There are three parameters: new column name, partition by columns, order by column. That's it. I will simply say new column name will be new dense rank, or let's say dense rank column. Then partition by column will be month, and I already know this is the month. I can just show you. This is the month. Yeah, month. This is the month. I need to just pass it here. Then I want to apply order by on unit sold. Perfect. That's it, bro. That's it. When I will be just running this, okay, I can simply store the result of this particular function call into, let's say, my df new, because obviously we are applying operation on that one. So just run this and I will simply write df new dot display. That's it. I didn't write any particular code of dense rank. I didn't write anything. I will simply show you the results. Perfect, man. See, perfect. Next level. So this way you can actually use your class so many times without worrying anything, like without worrying for anything. This is so cool. And if now you want to just create your other functions, you can just definitely create it, obviously. So let me just complete those two functions as well, so that you can just create those functions in your notebook. Okay, perfect. Just take care about the indentation in Python because it is really important. So this will be my rank function. Columns will be same, and just this function will be changed. Perfect. Then there will be another function, def. Then this will be my row number. Perfect. And then yeah, everything should be same. So I can simply rerun this class, and this time you will say I will create an object. I will obviously change the default parameter, default attribute. This time I will call row number, or let's say rank function. Okay, let's call rank function this time. Let me just see what will happen. By the way, you can see the results here. 1111178 by 7. Like, why we have 7 and there we had 2? That is the basic definition of like difference between rank and dense rank. In dense rank, it just starts the counting for the next number just after that particular number. Let's say it is like 11111, it will start the counting from 2. But in rank function, it will start the counting after the number of times it appeared. So it would have appeared 6 times, I'm so sure. 1 2 3 4 5 6. That's why we have 7 here. See, now when you have this particular class, see this one, you do not need to worry at all. If you want to use this particular class in your organization, what you can do, there's a tip for you. If you're already working in an organization, your manager will be really happy. So what you can do, you can create a separate notebook. Okay, separate notebook of this particular class, and every time you can import that notebook. Yes, you can import a notebook in Databricks using a command call. Let's say I will just show you. Let's say I will be deleting everything. because I will just show you how you can import a notebook. That is a bonus. That is not a real-time scenario. That is just a bonus. So let me just delete all the cells. Okay, let me just delete all the cells, and I just want to keep this thing only. Let me just remove this as well. Everything, bro, everything. Okay, so now this particular notebook class is just carrying your class. That's it. That's it. So what I can do, this is just a tip if you want to happy your manager, if you want to just make him feel happy or her happy. So what you can do, you can simply create a new notebook. Okay, you can simply create the new notebook, and yeah, simply go to workspace, just create a new notebook and simply say import, because I will be just importing this. Perfect. So in order to import a notebook, there are like two ways. First of all, obviously using dbutils dot notebook dot run. Let me just show you in the documentation if I can just find uh, dbutils notebook run in Databricks. Let me see if I can find. Yep. Let's see if we have anything. So as I just mentioned, there are like two ways. One is percentage run and second is dbutils.notebook.run. Both the ways are fine. I personally like using this because we can also pass parameters if we have any parameters in our notebooks. So I will just show you both the ways. So it is saying that if we just write percentage run, okay, if we write percentage run, we can simply need to write percentage run and then we just need to define the location. And within the percentage run, we do not need to define the whole location, but it is always good to define the whole location. Okay, very good. By the way, it's sunset time, bro. That's why you're just having orange light. Okay, okay. Next thing is dbutils dot notebook dot run, and after run we just need to define path and then timeout. After how much time we should just say, hey, your notebook is timed out, we are not running it anymore. And arguments, if we have any arguments, means like parameters we can just pass in the form of dictionary within this. So I will just show you both the ways. See, notebook name, obviously dbutils.notebook.run. Okay, notebook name, then 60. And why it is just given the notebook name? Because if you're importing notebook and the running notebook that you want to just use is both like are both under at the, what are you saying, Ansh? Are both under the same folder, then you do not need to define the location, you just need to define the name. That's it. And then obviously timeouts, and then it is the argument. Argument is for like parameters, if you have any, otherwise no need to worry. Okay, okay. Let me just show you now. So when we run this, we can simply use relative path. Okay, so relative path is obviously this and class, and I doubt it will just allow us to, oh wait, I doubt it will allow us to run this because, yeah, timeout seconds, let me just give 10, but I doubt failed to comment. Yeah, because we cannot use utilities in the free version now. See, so we have a workaround. We can simply use percentage run sign. Okay, then I can simply say dot, oops, dot. So this is advantage when we have the same folder for our notebook that we are importing. Okay, and in which we are importing, both are under the same folder. Then we can simply use relative URL, and this is the relative URL. We do not need to define the folders before that, so do not need to worry. So just a quick one, if you have class in the folder just one level lower the hierarchy, just forget about it. No, I didn't say anything. So simply run this. So it will run. Oh, perfect. So you have successfully imported this library, or let's say you have imported this particular notebook. Now you can simply create obj equals, and what was the class name? Window functions. Simple. It will run. See, you do not have any class. You do not have any class in your import notebook, but you have imported this particular notebook, and now you can simply use all the functions defined within this class. So this is a quick tip for you. You can just use this in your organization, and you can simply create a class, and you can import that notebook in your current notebook, and you can simply use the functions. And you will simply say, hey, you do not need to write functions every time, you can use this. Obviously it is a rare scenario, we should not use Python as much as we can, but if you're using OOP concept, there's no other, let's say, alternative for it. We have alternatives for functions. Let's say we can just use so many functions inbuilt that are inbuilt in PySpark, but if we have to use OOP concepts, then this is the scenario. I hope you loved it. I hope you loved it. And let's see how. So we have a new scenario. It is saying create a conditional column. Conditional column. Yes, based on the units solved column. So this time we need to actually create a conditional column, and it is really important to know how we can just create conditional columns without using if else statements. Bro, we will not be using if else statements. No, that is why this is one of the most important things. This is not the difficult thing, but this is the thing that you should know. Okay, so let's quickly see how we can just do this. So this is our data, like this for autoloader. I can simply copy the code from here and I can simply create a new notebook. Yep. So this time I will simply say conditional column, because conditional columns are like your bread and butter whenever you are working with any data. Okay. So let's say this is our DF. Let me just display it. Perfect. So these are having 95 records. Okay. So we want to create conditional column according to the scenario based on units sold. So the scenario is, as you can see, we have 1, 2, 3. So what we will be doing, so most of the times we have 1, 2 and 3, and sometimes we can have 4, but we don't have this particular scenario. So the thing is, we want to create a new column which will be the conditional column, and it will say 1 equals to low, 2 equals to medium, 3 equals to high. Make sense? Simple. I told you it is not difficult, but you should know how to use it. Okay. So I will simply what I will simply do, df equals df dot with column. Okay. Df dot with column. Perfect. Then I will simply say conditional column. Perfect. Okay. Then I will simply say, now I need to just define the transformation, right? So what is the transformation? Transformation is when else statement, when otherwise statement, whatever you want to say, when otherwise. Okay. So I'll simply say when column, or let's say just the directly the column unit sold, column of unit sold, okay, is greater than or let's say equals to 1. Okay, equals to 1, or let's say equals to 1. Okay, then I will simply say, then just put low. Perfect, low. Then I want to add multiple conditions. That is the scenario. We want to add multiple conditions. So I will simply go to next line and I will simply say dot when. I will add another when. So column unit sold equals to 2. Then simply put medium. Now after this, otherwise just put high. Perfect. This is the column that I want to like create, and obviously I need to just first import the libraries. So I'll simply go to code and from PySpark.sql.functions import asterisk. Perfect. Let me just run this. Okay, so now I can simply say df.display. Wow, let's see the result. Oh my god, very well done. See, we have successfully created the conditional column. Now I will tell you one more thing. Okay, this was done by PySpark. Now a lot of you will be saying, hey, we can just do this as well. So let's say def. By the way, this can be the question as well, how you can just perform the same thing using UDF, which is user defined function. Okay, so let me just cover that part as well. So def, and I will say conditional column, and obviously I will take the parameter. Then what I will do, I will use if else condition. If x equals to 1, then I will return low, otherwise elif x equals to 2, I will return medium, okay, else I will return high. Perfect. Okay, now let's say I want to create a column, okay, conditional column, and I will simply say new. This is my new conditional column. Instead of writing all this, what I need to just use, I want to just use conditional column. That's it. And on which column? We will be applying this on units sold. That's it. This is the thing that we need to do. But before that, we need to first convert this function to UDF. And how we can just do this? We simply need to pick this name, and then we will be using UDF. Okay, then we will insert the function name. So now this function has become UDF. Conditional column is not defined. Okay, let me just run this. Let me just run this again. Perfect. Now this conditional column has become UDF, user defined function. Now Spark can identify this as a function. Let me just run this. Conditional column is not defined. What? Conditional column is not defined. Let me just run this. Okay. Oh, condition column. It is not conditional column. Okay. So now let me just run this. Okay. Now you will see same results using my Python if else statement, but it is not recommended. If we have the alternate functions available in PySpark, we should not use Python functions because our process will become slow. Yes, the reason is very simple. Let's say this is your executor. Okay, so in executor we just have only JVM processor that executes your code in JVM, that is Java Virtual Machine, and which only understands Scala or Java. So when you use Python, okay, because all the transformation will be actually happening on the executors, so in that particular scenario it needs to just add a Python processor as well in order to execute your Python functions. Yes, okay, so that's why it is not recommended to use Python functions for transformations, because we have like lots of functions available. But if you're using a complex logic and if you have to use, you have the liberty to do that. You can. Okay. Okay, let's see our next scenario. What is that? So this scenario, this particular scenario, you will be dealing when you will be working with, let's say, financial data, and this will be the requirement from most of the financial stakeholders. And the scenario is, as you have already seen it on the screen, find the cumulative sum of units sold per month. They want to just find the cumulative sum of units sold per month so that they can actually estimate the sales. So for those who do not know what is cumulative sum, so let me just explain it in just a minute. So let's say this is your month. Okay, this is your month, and this is your sales. So let's say this is your month one, month one, month one, then month two, then month two, and these are your sales like 5, 5, 10. These are like for second month 10, and then 5. So in the cumulative sum column, what will happen? This is cumulative sum. Okay, what will happen for the first month? Obviously we have like multiple months because there can be multiple days in a month, bro. Come on, man. So 5. For the next iteration, it will add both the records. It will become 10. For the next one, it will just add this as well. It will become 20. Then it will be reset for the next month. We need to just apply this logic. Don't worry. Yes, we need to explicitly add this logic. Then it will take 10. Then it will take 15. So we need to achieve this. How we can just do this? So the thing is, we have to convert our normal aggregation functions into window functions. So if you know how to do this in SQL, it is good. If you do not know much about this in SQL, do not need to worry, bro. I am here to tell you everything. So this is a kind of real-time scenario which you will be tackling a lot of times. It is not just about the financial data, but this is a requirement that can be asked by any stakeholder. Cumulative sum, cumulative sales, cumulative revenue, anything. Okay, anything. So let me just tell you how you can do that. Do that. So let me just take the same data frame because we have the data frame ready here. So as we know that we want to just find the cumulative sum of units sold column based on the month. So what we will be doing, I will simply create a new column, tf dot with column, and I will simply say come sum. Okay, I know it's not a very good name and ideal name, so you can simply say cumulative sum or come sum per month, like anything you do, you need to just name it. Okay, so come sum. Then I will simply say sum of, hey Ansh, you cannot use sum without using group by. I know. That is the thing. We need to convert our normal aggregate functions into window functions. Can we do that? Yes, we can do that. Okay, sum of which column? Sum of units sold. Sum of units sold. Hey bro, sum of units sold. Okay, then I will simply say dot over. Yes, now it has become the window function. Okay, dot over window dot partition by. I have not imported window, so let me just quickly do that. From PySpark dot SQL dot window import window. Okay, perfect. So window dot partition by will be on month. Okay, then dot order by will be on order by will be on order by will can be on anything, because we are not using any ranking. We just need to do the grouping. So we can simply say like anything, maybe on month. Not a big deal in this particular scenario. Simple. Let me just display the data. Let me just display the data, and you will actually see what we have done. Okay. Okay. Now you will see the sum. So this is month one. Month one, you will see 1 plus 3 4, 4 plus 2 6, 6 plus 2 8, then 1 9. See, whoa, we have 86 86 86 86 86. What just happened? Yes, that's why it is a complex scenario. So you will say, hey Ansh, Lamba, it has just aggregated the data based on the month. What it has done, it has aggregated the data like for whole month, and then it has shown us here 86 86 86, and then for new month 51 51 51. See, so one thing is clear, that we have successfully converted our normal aggregation function into window function. But in order to just do the cumulative sum, we need to do one more thing. And now we need to just change the data within the window functions. Okay. Okay. Okay, let me just show you. So there's a functions, not a function, like there are functions within the window functions in order to change the data by actually going inside it. So you can just say it is called preceding values and the data so far. I will just tell you. So what it will do, instead of calculating all the data once, we will say, hey, because window functions work on the row level, not on the column level. We will simply say, hey, when you reach here, just find the sum till here. When you reach here, just find the sum till here. When you reach here, you just need to find the sum till here. Do not find the sum of the whole column. And in order to do that, let me just show you how you can just achieve this. So we will simply write one more thing. Let me just copy this code here so that you can feel the difference. Okay, so what we need to use, we have something called rows between. As I just explained you, that we just need to say, hey, we need to define that only read, let's say your window function has reached to the row number 2. We will simply say read all the records before this row, like this one, and read the row till this row only. That's it. Do not go after this row. So just tell me what will the answer when it will just reach to the row number 3. It will read all the records before this row and till this row only. It will stop here. It will stop here. It will stop here. Okay, I know this is very deep knowledge in the world of SQL, but yeah, we just follow the same things here as well. So what we need to use, we need to use a function called, within over function we will simply use dot rows between. See, rows between. And what I can just do one thing, I can simply go to the next line so that you can actually see what I'm doing. Okay, let me just go to the next line. Dot rows between dot rows between, then what will be the rows that I need to pick, like starting point and ending point. So we have something called window dot preceding values, I think. Yeah, I think window dot preceding. Now let me just go to the previous line so that I can just see the exact function. So dot month dot rows between, then we can simply say window dot preceding, yeah, unbounded preceding, yeah, this one. So we have something called unbounded preceding. That means all the rows before the current row. Okay, simply pick this. This is our unbounded preceding. This is our first row, like first, like initial point of the window function. Then what will be the upper limit? Upper limit will be window dot, or let's say capital window dot current row. That's it. So this time it will simply stop at current row. And by the way, one more tip. By default, when you convert any aggregation function, or let's say any window function, it uses rows between function every time. Ansh, we haven't seen any rows between function, you are just lying. No, by default it uses this. It uses unbounded preceding and window dot unbounded following. Unbounded following means all the records after this row as well. So you do not trust me, let me just run this and you will see the exact same result that you are seeing above. See, let me just show you. 86, 86, 86. But the moment you will change this upper limit to current row, it will work fine. Window dot current row. I was so happy to just tell you this thing in detail so that you can actually feel. See, 1, 4, 6, 8, 9. If you just sum 1 plus 3, 4, 4 plus 2, 6, 6 plus 2, 8, 8 plus 1, 9. Got it? Happy after learning this deep knowledge? After having this deep knowledge? Happy? You are happy? Then I am happy. Okay? So this was our scenario related to your fundamentals, your SQL, your deep knowledge, your core knowledge. Okay? That is why I say, when I was thinking to create real-time scenarios in PySpark, I was so sure, like I will not just show the basic transformations, like, hey, how to just create this, how to just convert from one data type to another. You can easily do these things. We have ChatGPT, we have DeepSeek. We can easily go to the ChatGPT. We can simply say, hey, just do this. It will easily convert those columns. But in order to work with this, you need to understand, you need to have that particular skill, you need to have that knowledge. I'm not saying that ChatGPT cannot do this, but you will not understand anything what it is given. You will simply copy and paste the code. But now when you actually know what actually is happening behind the scenes, you can still copy and paste the code, but you know what exactly is happening. If any junior developer comes to you, any manager comes to you to make any changes, you can easily make the changes, bro. Just feel this. When you have the knowledge, you use ChatGPT to save your time, not for the sake of help, like taking help from it. Hey, I don't know this, just please help me how to run this, how to do this. No, you need to use ChatGPT smartly. You need to have knowledge, you need to have skill, but now instead of just writing again and again same things, you can simply go to ChatGPT and simply say, hey, just do this, just do this. Plus, in order to work with ChatGPT, you need to provide prompts, and you can only provide technical prompts if you have that technical knowledge, if you have that fundamental knowledge. Otherwise, it will just give you wrong code, and you will simply paste that, and you will see, hey, I'm just having errors. Okay, so I think you got the concept, like what exactly I want to convey. Okay, so let's see what is our next scenario. So, bro, another Python, another Python. So don't worry. This is simple. This is simple. Trust me, this is simple. This is just like your fundamental knowledge. It will just test your fundamental knowledge. So create a parameter. Just have some more more coffee this time, have some more focus, because this is really amazing, and this is actually combining 3 to 4 questions together. And the thing is, create a parameterized notebook. That is the first thing, which takes the values from the user. Second thing, and use it in your filter criteria. Third thing, then also create multiple outputs based on this parameter. Fourth thing, boom. Very well done, Ansh. Very well done. These kinds of scenarios will help you to crack the interviews. Okay. Nothing. I just got the text. Really, I get some text from the people. Really, once in a blue moon, like navy blue moon. So create a parameters notebook which take the values from the user. So what we are trying to do, okay, let me just illustrate this. This is your notebook, okay, this is a notebook, and this has a parameter. We know that we cannot create dbutils.widgets, but it's fine. We can just use parameter. It's fine. Okay. We have a parameter. That is the first thing. We will create the parameter. Okay. Very good. It will take the values from the user. Okay. Very good. And based on this value, we will be creating a filter criteria. Wow. Yes. A filter criteria. Okay. Very well done. When we have this filter criteria, we need to use this filter criteria to just create multiple outputs. And let me just align this with our data. Like, what is what is the scenario? So let's say we have brand, or not brand, like unit sold. Okay. So let's say we do not know how many units are sold. Currently we know like it is either 1, 2 or 3. Let's say in future they'll be having like 4 units sold in a day, 5 units sold in a day, 6 units sold in a day. It can happen. Very well done. So what we need to do, we need to take this parameter from the user. Okay. So user will tell us how many values they want. Let's say user tells, let me just create everything, 1, 2 and 3. Okay. Because for now, because we just have like 1, 2, 3 values. Okay. Let's say in future they have like 4 and 5, like 6. Okay. So what we will be doing, let's say we have 1, 1, then 2, 3 and 3. Okay. Then what we need to do, we need to filter our whole data frame based on this. That means I want to create df1 with only and only unit sold equals to 1. Then df2 will be equals to unit sold equals to 2, and same with df3. Okay. Now second, like the next step is we need to create multiple outputs based on this information. That means I want a different output for df1, I want different output for df2, I want different output for df3. This is a special business requirement that can be asked from you, and where you need to just prune the data, and you just need to just provide the data frame which will be having a particular condition, a particular filter. That's it. Okay. Let me just show you how you can just achieve this. Okay. Let me just show you. So I have created a new notebook. Okay. Let me just connect this notebook to the cluster, and I will simply say a loop, because we will be running a loop. Okay. So first of all, we will simply import the libraries PySpark dot SQL dot dot functions, import asterisk. I just had a bowl of rice and now I'm feeling good. Oh man. So Lamba from PySpark.SQL.functions import asterisk. Okay. So now first of all, I will just paste the code that I have copied from the previous notebook. It is just the same code. Okay. So now the scenario is, first of all, let me just run this code. Okay. Then see, we have like different values, different you can say total 3 distinct values within the unit sold column. Okay. Makes sense. Okay. Makes sense. Now I will ask the user to provide this particular information. Okay. So first of all, I will simply create dbutils. I know we cannot use it, but still I'm just using it for you. dbutils dot widgets dot text. Okay, then you can simply say, hey, unit sold, unit unit sold, and then it will just pass the values. Okay, let's say 1 2 3. It can pass the value like this. Okay, but we have not we do not have the access to utility, so not a big deal. We can simply create our own variable for the sake. So I will simply say variable units sold. Okay, then I will simply create the list. Our list will be having 1 2 3. So these are the distinct values that we have in this particular column. Okay, very good, very good. So this is done. We have successfully read the data. So now the scenario is here. So I will simply create a loop, for loop. If you do not know about for loop, so let's say you have an array 1 2 3 4. Ansh, Lamba, can you just identify which is 1, which is 2, which is 3? Okay, my bad, let me just rewrite it. Okay, let's say you have an array 1 2 3 4. Oh man, this boy is a mess. 5. Okay, so this is your array. Okay, this is your array. So if you want to just iterate through each value, you create a for loop. You create a for loop. You simply say for I is just a variable, and you simply say in what? In this list. Simple. Then for every iteration, this I variable will get this value 1. The next time it will get 2. Then third time it will get 3, so on. Okay, just a quick revision for your Python. Okay, so I will simply say for I in what is my list name. It is called var unit sold. If I just run this, have I run this? No, that's why I was not having the recommendation. Okay, for I in var unit sold. So when I have the I equals to 1, then what I need to do, I simply need to read the data frame. Okay, so I'll simply say df1, or let's say simply df equals to, I will simply copy this code. Okay, like from here I will put it here. Then I will simply say dot filter. Okay, column of units sold equals to 1. Makes sense? Very good. So this is my df. Okay, so now I have hard coded this one. I don't want to hard code it. I will simply say equals to I. So every time it will be having 1, it will just, like, every time the value of I equals to 1, it will just filter my data based on I. Okay, once it has filtered the data, I want to say df dot write. Okay, dot format. Let's say I want to write the data in CSV format, the same format. Then I will simply say dot mode is append. Okay, perfect. Then I will simply say dot option. Yes, this is important. Path. Now, as per the scenario, we need to create a new folder, a new location for each data frame. So how we can just do that? Let me just copy the location. Okay, till here, row source. Okay, so this is the raw source. Let's say I want to create a new folder called loop data. Okay, and within this I want to create a folder for every value. Let's say I want to create a folder called units sold equals to 1. So now I will not hard code 1. I will simply use f strings. So this is my f string. Now I can simply say I. Perfect. So every time it will be using this f string, and it will just create a new location for my data. You want to run this? I can just show you, bro. Let me just say dot save. Let me just run this cell. Not give me the errors right now. I'm not in a mood to debug. Okay, perfect. This is successful. So what is the output you are expecting right now? What is the output? Output should be 3 different folders with unit sold equals to 1, unit sold equals to 2, unit sold equals to 3. Simple. This is the output that I am expecting. Let's see, was that successful? Let me go to catalog, go to dbfs, go to file store and just search your data folder as loop data. Perfect. Ansh, Lamba, love you. Unit sold equals to 1, unit sold equals to 2, unit sold equals to 3. Three different folders based on the values provided by the user, not me. We just ran a loop and we just used dynamic content instead of static content. Okay, so let's say tomorrow morning in the pipeline they have just changed the parameters for like 4, 5, 6. We don't care. We will just simply filter the data and just provide to the stakeholder in this particular format. Simple. If you just click on this folder, you will simply see the CSV file. See, this is your CSV file. Let me just expand it. So this is your CSV file. As you can see, the extension, it was CSV. Let me just hover over again and you can see .csv. Simple. Very good. So this was your scenario. Okay. Now let me just show you the next scenario what we have in this video. Let me just show you. So find the skewness in data by querying the number of records per partition. This is something crazy. This is something crazy. This is something that you should know that how we can just actually create this. Okay. So it is just asking you to just query the partitions. Obviously, we just process the data in the form of partitions in Spark. Okay, and it is saying also rank them accordingly, like which partition have the like has the like number maximum number of records, then second, then third, then fourth. There are like so many small parts that we need to just cover in this particular scenario. So let me just tell you how we can just do this. So if I just go here, let me just create the new notebook. Okay, and let me just copy this cell. So I'll simply go to workspace, create notebook, and then I'll simply say this time I will call it as partitions. Perfect. Oops. Perfect. Perfect. So I will simply first of all import the libraries from PySpark .sql.functions import asterisk. Wow. 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 So let me just run this. Let me just run this. So as we know that we have this data, okay, and we always process our data in the form of partitions. Makes sense, right? Makes sense. Okay, and we don't know like how many partitions do we have for this particular data. Okay, so we can just figure it out, and I will just also show you how you can just repartition your data. But by the way, where's my water? By the way, my throat. By the way, by default, we get one partition of 128 MB, 128 megabytes. This is like the default partition size that we get. So I am expecting, let's say, only one partition because we do not have any data more than 128 MB. So let's still see. So for that, what do you need to do? So we have a function called Spark partition ID, which tells us this particular record this particular record is stored in a particular partition. Wow. Yeah, so this is a function that we have. Let me just show you. Let me just create a new function, new column with column, and I will simply say partition id. Okay, then I will simply call that function. I will simply say spark partition id. See, this is the partition id. Let me just run this, or let me just display it. Perfect. Let me just scroll it down. So by default your partition starts from 0. Do not say like, hey, we do not have any partitions. No, partition starts from 0. So as I just mentioned that we just have like one partition, like 0th partition, because we do not have the data more than 128 MB. So obviously it will not create your partition like multiple partitions. But yeah, we can create multiple partitions. So let's say I want to repartition my data. I will simply say df.repartition, and I want to create 4 partitions. Okay, let me just do that. So once I have run this thing, now if I just rerun this, you will see something else. You will see that your data is now having value 0, 1, 2, 3. See, that means this data frame, which was converted into only one partition, now having 4 partitions. Wow, very good. Now we have manually created the repartitions, but let's say if in the real world when you are just working with TBs of data, okay, then your data will be stored in so many partitions, right? And when you are just applying joins, okay, and when it applies joins, like it just reshuffles the data. So at that particular scenario, it will be very difficult to just, obviously now we have AQE, it is called adaptive query execution, which takes care of all the skewness, which takes care of all the things, but still you should know like how to actually find how many partitions do we have and how many records do we have per partition. So how we can just do that? So now as you can see, we have partition ID column. So what I will do, I will simply go here and I will simply say dot group by, okay, and I'll just apply group by on top of this column, which is called partition ID. Okay, and then I will simply apply count aggregation because I want to find the count. Okay, let me just say df.display now. Let me just let me just run this. Perfect. So it is saying your 0th partition has 23 records, then this has 24, second has 24, 3 has 24. We do not have any kind of skewness because obviously when we use repartition, it distributes data evenly. That is the best thing about repartition. Okay, when we apply callies, it does not it does not give us the evenly distributed data. Why? Because it does not shuffles our data, it just callies our partitions, it just merges our partition. That's it. So if you want to just rank this data based on the transformation that we are asked to do, so what you can do after this, you can simply say you can simply create another column after this. Let's say dot with column, and then you can simply say ranking. Okay, then you can simply create dense rank. Okay, then dot over, then window dot order by, and then what will be the column name count. Okay, then dot dsc, and we need to encapsulate in column. Perfect. Column count dsc. Okay, let me just close this as well. So this is fine, and at the end we just need to do this should work. Obviously we need to import window PySpark.sql.window, import window. Okay, now let me just run this. Let's see what we will get. Okay, first of all, we just got this thing. By the way, this was not the intent. We need to apply partition by as well instead of just this. By the way, if you just see, it has just given us the partition ID 0 and count equals to 4 and ranking equals to 1. So it has just done something else. So instead of doing this, you can, so by the way, it has not done something else. So it has just applied dense rank function on top of your, let's say, count. Okay, and count was obviously 4 for 0 0 0. So obviously like you can just apply same thing like dense rank again and again, like the same way we have just used dense rank so many times, or you can just simply use order by as well. So we have our next scenario which says query the data frame using SQL as a table. That means we do not need to actually create the table, but we need to query data frame as a table. Also, the object that we'll be creating, this object should be accessible throughout the cluster. That means if we have like, let's say, hundreds of notebooks attached to the same cluster, so all those hundreds of notebooks should be able to access this view. Wow. Let's see how we can just do it. It's very simple, by the way. So let's say you have a data frame. As you all know that we have the data frame, or let me just create a new notebook. Okay, and let me just copy this code, or we can just do it here as well, and we can simply say partitions and views. Oops, partitions and views. Okay, simply say df.display. So what we will be doing, what we will be doing. So this is your Spark code. Okay, then I want to convert it into an object which can be accessed as a table, but it should also be accessible throughout the cluster. So in order to do that, I can simply create a view on top of my data frame. And how we can create it, simply say df.create or replace temp view. Okay, then I can simply name it as temp view. That's it. When I just do this, I can simply query this data frame as a SQL table, and actually it is not a SQL table, it is just a view. See, perfect. But that is not the complete solution. So this is this notebook. Okay, and we know that this is my cluster, that is my cluster. Let me just try to run this code into any other notebook. Let's say this one. Let's say this one. Let me just run this. It will throw an error. Wow, it will throw an error. Let me just do some changes, and then you will see it is working fine, and we can access this view through any notebook attached to the same cluster, and it is called global temp view. Okay, it is called global temp view. So we can simply create global temp view this time. Okay, let me just create it here. Simply say df dot create or replace global temp view, and I will simply say global view. Perfect. Now I can query this. I can simply say select asterisk from one more thing. In order to just use global temp views, we have to use global temp. Then you need to just name it global view. Let me just run this. Perfect. Otherwise it will not be working. Now you will say, hey Ansh Lamba, just run this cell from another notebook. Okay, not a big thing. We can just do the same stuff here. See, now let me should run it. See, now it is working fine. It is a different notebook and it is attached to the same cluster. That means it is working fine. So this is a kind of session scoped views, because once our session is turned off, then this global view will be killed. Okay, let me just remove it from here because it is not required in this particular notebook. Okay, perfect. So this was your scenario. Okay, now I want to just discuss a small but really important scenario. Let me just tell you what's that. So this is a cute little scenario that you should know, because this will just save you a lot of time in just like preparing your notebook for, let's say, deployments and also. So I have created a new notebook. Okay, and let me just quickly name it, and I will simply say error handling. Okay, because in this particular notebook we'll be just handling the error using Python, and that is the like one of the most important scenarios, because this is not a special scenario or this is not an independent scenario, but this scenario can be merged with countless scenarios, because on every step you may need to just handle the errors. So let's say a very common example and very small example, but obviously you can just use this application in so many scenarios. So let's say, oops, I want to read the data. Let me just go to recents. So let's say I have this data. Let me just try to read this data. Error handling. Okay, let me just try to read this data. So let's say if I just read this data, obviously I can just read the data because I have files, I have data here. So obviously it will just display the data, right? So we need to wait for, let's say, a few seconds. By the way, the next scenario is really interesting. So I'm really excited for that one as well. That is like one of the best scenarios. After that class scenario, the next one is like killer. So as you can see that it worked fine. So let's say I want to read this data, and the file name is first. Let's say if I just run this now, what will happen? It will obviously throw an error, obviously, see, and my notebook will stop running at that particular moment. It will not move further. What if this particular cell is independent? What if even if we have errors in this cell, we need to just move forward. We need to move forward. We need to just run the cells after this particular cell. How we can just tackle this scenario? How? So we will be using error handling features available in Python, and it is called try except. So what I can just do, I will simply say try, and when I say try, oops, yeah, when I say try, so what it will do, let me first of all just remove this df.display, or let me just keep it here, no worries. So it will just try running this particular code. If it runs fine, it's fine, it's okay. But if it fails, I will simply say except, and then I can simply pass any kind of print statement if I want to just give. So I can simply say, hey, you have an error, but this will not stop this notebook to run the further cells. Let's say, let me just write another cell here. I simply need to say print hello my lovely data fam. So now you know that this particular cell will throw an error, and it will not just go forward. Okay, we have just seen that. Let me just click on run all, and you will see this cell will run fine. Then it will just go to this cell as well, and this will also run fine. Let me just click on this, run all. So Ansh, Lamba, what actually happened? This is an error. This cell contains an error. How it can just go to the next cell? Bro, the answer is very, very, very simple. This is called error handling. This is called error handling. We have try, we have accept. Then even if we have the error, see the output of this one, it didn't run this. Why? Because first it tried running this, then it saw an error, then it just went to the next step, which is accept. And whatever I have put here, it will just display the same stuff. I have put, hey, you have an error, and you are seeing the same thing. Then it will just move forward to the next cell. That's it. That's it. And now you do not need to rely on, hey, if I see the error and if my subsequent cells are not running, what should I do? Now you know what should you do. So there's one more addition that I would like to highlight. Now you will say, hey, it's fine that it is not running. What if I have to see the error? Like, what is the error? Valid point. Very valid point. Because obviously we know that we have an error, but what is the error? You will say, hey, we can obviously look at the code. We will see the error. What if you are writing 20 lines, 30 lines, or 50 lines of code within one single cell, and why you are wasting your time? Because I can save you a lot of time. How? Let me just tell you. We have something called exception, and we can just import this exception as E. Now, what is this E? Basically, this is nothing. This is just the alias for exception. So basically, exception will give us the error. What is the actual error? So when I just write, hey, you have an error, and I will simply say hyphen, and then I will simply put this variable called E, and I can simply use f string for that. Now let me just click on run all for one more time. Then you will simply see this ran fine, and this time we have the error as well, that path not found. Path does not exist. Sorted. Sorted life. Sorted life. I think so. I think so. I think so. So far sorted. So this was your error handling, and this is the way like by which you can just handle the errors, and you do not need to worry about like, hey, our notebook is stuck at a particular point, how we should just move forward. So this is the way you can just move forward. And as I just mentioned, that you can just use try except method in like anywhere, right? Because this can be handy throughout the notebook, right? Very good. So this was all about error handling in notebooks, or error handling in Python with notebooks that becomes your PySpark. Or you can say error handling in PySpark using Python, whatever you want to say. So I just wanted to show you. Okay, perfect. Now I'm really, really, really excited for the next scenario. And this is, by the way, if I have that book, I don't think so. I have that. This particular scenario, is the, you can say, condensed form of the whole chapter in that particular book, which is written only for Delta Lake. Only for Delta Lake. This is the condensed knowledge that I'm going to provide you next. This is the whole chapter. And I think it's chapter number 8, I guess, in that book. It's called Delta Lake Up and Running. It is the condensed form of that chapter. And I'm really, really excited to provide that knowledge to you. And let me just show you. Let me just show you. Let me just show you. So the next scenario is, this is your next scenario. Wait. Yeah. I forgot my marker. So yeah, here it is. So you need to incrementally stream. This time you are just incrementally stream the data from a delta table. Instead of streaming files, instead of streaming CSV files, instead of just using those CSV files, you need to just incrementally stream the data from a delta table and handle the updates as well. And let me just tell you, this time it is special. Why? Because this time you do not need to use Autoloader, and you should not use Autoloader. Why? Because this time we will be using Spark structured streaming with Delta Lake. Both are different stuff. I know the parent principle is Spark streaming, but concept is not exactly the same, bro. Not exactly the same. Because Delta Lake works on its special architecture where we just use a transactional folder, or let's say Delta log. This part of the video is like very special, bro. Just trust me, because I will be covering so many mini scenarios within this parent scenario. Just trust me, because I'm gonna provide the whole knowledge of that particular chapter, and you will feel like, bro, and you will definitely say, I love you. I love this video. Obviously, you will not say I love you. You will simply say, I love this video. Trust me, and you have to say this in the comments. I love this video after this scenario. Otherwise, don't don't do not talk to me, or don't talk to me. Okay? And I'm really serious this time. I'm really serious this time, because love should be reciprocated. And I also learned this after forget about it. Okay, so are you excited? Are you excited? Let me just create a new notebook, and let me just tell you how we will be just learning this thing. This is special. This is special. Let me just show you. So let me just create a new notebook, and this time I will simply create a new notebook with the name Delta Stream. Buckle up, bro. Buckle up. So first of all, let's quickly create our source for a delta table, and it is really easy. You already know how to create the delta table. Okay, if you do not know, let me just tell you, bro. I'm here. So simply say create table, and you can simply name it as delta source. Okay, delta source, simple. Define the schema such as id, int, then name, let's say string, then salary, and then simply say int. That's it. Okay, then using delta. Now you'll say, hey noob, why are you writing delta? It is by default. Okay, pro, Mr. Pro, Mrs. Pro, Miss Pro. I really like writing using delta, because it makes our code readable and it promotes readability. So I am a noob, I know. So don't worry. Using delta, then we will simply say location, and location I will pick this time file store. Okay, then within this I will simply create delta source. Perfect. Delta source. Simple. Do not make it complicated. And maybe I can simply create another folder between this, and I will simply say source 1. Why source 1? Because I'm just creating so many mini scenarios, I told you. So let me just create this. Okay. So it will just create a delta table, not a fancy term, not a fancy thing, but you will see a lot of fancy things. Don't worry, just be with me. Okay. And in order to do this, I actually have 2 more subcategories of this scenario because of this particular new player in the market. It's called deletion. Wow. Deletion vectors delta lake. Yeah, this one. So this is the new entry in the world of Databricks, deletion vectors. So scenario is totally different. Don't worry, I will just explain you everything. But first of all, we will turn off deletion vectors, then we will turn on deletion vectors. By the way, if you do not know what are deletion vectors, so here's your boy Ansh Lamba will tell you. Deletion vectors is a type of, again, out of scope topic, but when you are on this channel, nothing is out of scope, because everything is related to data engineering and anything can be asked in your interviews and anything can be asked in your day-to-day activities. So nothing is out of scope. If someone says, hey, this is out of scope, just simply say, bro, FO, simple. So what are deletion vectors? Deletion vectors are basically the new approach to optimize the storage cost. First of all, I will turn it off and then I can just also explain it when I will be just turning it on. Okay, so that we will be just aligned with the solution as well. Okay, sorted. Trust me, I will just explain everything, bro, don't worry. So first of all, let me just turn it off. So we can simply turn it off for a table and for a cluster as well, but simply I will first of all turn it off for a table. So I have created this table. Okay, let me just turn it off. By the way, they have given the code to turn it on, and people like me use it for turning it off. See, so Ansh, Lamba, why they have provided the code if it is automatically enabled? So the thing is, now it is automatically enabled, but before it was not automatically enabled. We had to turn it on, but now they have just turned it on automatically. So instead of writing true, I will simply write false. Simple. Just hit this command and now it is enabled, and now it has just disabled the deletion vectors. Now we are good. So what I will be doing, I will simply insert some data into this table. Okay, obviously we need some data, bro, in order to just start the stream, right? Okay, so let's say insert into, okay, and then table name is delta source. Perfect. And then, wow, simply write values, and then you can simply provide values such as 1. Name will be, let's say, what is your name? Let's pick a random name. Okay, name is Priya. Who is Priya? I don't know any Priya. Wait. Let's say ABC. Let's say Priya. Normally, if you are one of the Priya, you can just comment down. Let's pick random names. So salary is 100. Oh, don't feel sad, by the way. Like 100 can be like maybe per hour, $100 per hour. So it's fine, right? Now it's fine. Okay. So next thing is, let's pick second ID, and this time let's pick a boy. Okay. Whew, why it is so difficult to pick names? Because I don't know anyone. Okay. So Priya, and then let's pick Rahul. Watching Bollywood movies. So Rahul is earning more, $150. So sorry, Priya. No worries. So third. Let's say another girl. What are the names available for girls? Okay, Shanti. Shanti Priya. I think this was the name of an actress in the movie. It was a movie. Om Shanti Om. Shanti Priya. Okay, so she is earning the maximum $200. Okay, so first of all, let me just run this and let me just insert some data. Okay, so my data is inserted. Almost. Perfect. Let me just show you the data as well. So just to make you align. So file store. Within this, I have the table folder called delta source. Perfect. So within this is my folder for table. Very good. Simply see, this is my one partition. Now I want to stream this source, this delta table into my destination table. Okay, so where I will just put my destination table, I will simply put my destination table here, and I will make a folder called sync1, source1, sync1. Makes sense. So let me just create the stream. So now how we can just create the stream? It is very simple. So it is similar to Autoloader, but not exactly. So we'll simply say df equals spark dot read stream. Okay, then dot format, and this time you have to just tell delta. You do not need to just type cloud files. Simply delta, then you will simply say dot option. I don't think so we have any options, so we can simply say dot load, or if you just want to read the table, you can also use dot table, and it will be easier for you, and you can simply say delta source. Simple, makes sense. Very good. Delta source. So this should run fine. Now, obviously, let's write this data. Let's write this data. Okay. df dot write dot format. Obviously, we can just pick delta as a format. And yep, perfect. Then dot option. And option will be, obviously we need to define checkpoint location. Yes, we need to just create checkpoint location. That is the thing, because we do not need to create schema location. Why? This can be your interview question. Because your schema is automatically saved in your delta log, so you do not need to explicitly create another folder called schema location. Make sense? Very good. But obviously for checkpoint location, we need to just create this, and what will be saved inside this? That is the special thing. I will just tell you. Wait. So checkpoint location will be my this location. Where's the location? Yeah, this one. So I will simply create sync1 here. Simple. And I'll simply say sync1 instead of source1. Sync1, and within this I will simply create checkpoint. Okay, very good. Then everything is fine. Then dot option, and then path, and path will be same, but this time sync1. And within sync1 I will simply create data. Perfect. Now you're good to just start your query. Simply say wait, you need to also define dot trigger, and processing time is let's say 3 seconds. 3 seconds. Perfect. Then just simply say dot start. Let's run this. Write cannot be called on streaming. What? Oh, write stream. Ansh Lamba. Just say write stream. It's not write. Perfect. My stream is initializing. We are loading data incrementally from a streaming delta table, but wait, this is not the end. This is just the beginning of this scenario, because I am just making so many tweaks now. Just click on this. Just click on this. Then just click on this. You will see something special. Let me just collapse this. You do not need to see the jobs. So this is obviously reading your data. Obviously, Ansh Lamba, we know this, that it will just read the data. By the way, it has automatically read the data, and data was so small that you cannot even see that the graph going up. So if I just click on raw data, this is the thing. This is called QPL, query progress log, or I think query processing log. I think you can just pick one between these two. I think so it is query progress log, because it tells us like how it is just performing. There's one special thing. Let me just show you what's that. Obviously all the information are important which is written there, but there's one special thing. Let me just show you. This is the thing. Reservoir version. This is the most important thing, and this is the center of this scenario. And trust me, bro, this information is very hard to find. Trust me, I spent whole day when I was learning this, and I tested so many scenarios, and I had to sit and actually see like what exactly is happening. So now you are getting this information very easily, obviously in the best way, so that you can actually digest. So just be with me. I'm going to tell you what's that. This is the center of the whole architecture in delta table streaming. Why? Wait, let me just show you something called as versioning in our table. Okay, versioning in our table. So if I want to see the versions of my delta table, of my source, like source delta table, how I can see that? We have a command called describe history, and for that I just need to pick SQL, because it does not automatically pick describe command as SQL command. So describe history, and then you simply need to define the table name, which is delta source. Just run this. Bro, this is an amazing. Trust me, bro. Trust me. So. Hey, bro. Wait. Yeah. It's fine. So. Now, if you just see, this is my table. Okay. This is my table. So what it will do? These are the versions. Like these are the you can say this is a kind of history for the operations that are applied on top of this table. So for the 0th version, it says you created the table, obviously. For the version 1, it said that you set the table properties. It is correct. For the version 2, it says write operation. Obviously, we inserted the data. These are the 3 versions of the data. So now, when next time, when if you remember, what was the folder name that autoloader bro, just say autoloader. Okay, so what was the folder name that autoloader was using? It's called rocksdb. Okay, rocksdb was managing all the metadata, that this file is coming, this file is coming, this file is coming, using APIs. How Delta Lake is using that thing? It is not using any rocksdb. So what it is doing, it will say, bro, this is your query, and so far I have read this version, reservoir version. Okay, reservoir version, very good. So now let me just show you something else. So this is your reservoir version. So it says I have just read the data till reservoir version 2. Okay, very good, very good. So this is the reservoir version that is stored here. Why it is saying 2? Because it has read all these things, 0 1 2, 0 1 2. Okay, okay, very good. So now if I just go to catalog, okay, if I just go to dbfs file store, and then obviously delta source and sync one, you will see a folder called, obviously checkpoint, you will see folder called offsets. Within this you have 0th JSON file. In this file, in this JSON file, if you just see like copy path, okay, and if you just copy the, let's say this path, yeah, if you just query this particular JSON file, you will see that reservoir version as well. You will see that reservoir version because this information is stored here. So next time, let's say I inserted the data in this source table, let me just add one more cell and let me just insert this data again. Let's say these are the new records. Let me just insert this. You will see data is inserted. Just hold on. Data is inserted. Perfect. You will see something else. See. Graph is going up. That means it has read the data. Again, your new data. Now just click on raw data, and then you just need to check the reservoir version. Wait, just need to check the reservoir version. It says 4. Why 4? Why not 3? Why just tell me why not 3? Why 4? 4 why 4? Why not 3? Because this says reservoir version always says that you need to read the data from 4th. So when you just initiate the query, it will just tell you, hey, you have read the data till 2. But after that, after your initial run, it will only save the version from where you need to run next. That means, hold on, I am not done yet. Hold on. That means if I just check the versions, obviously you will see 3 versions, obviously. Perfect. You will see 3 versions. So now the reservoir version here says that if it inserts more data, you need to pull data from reservoir version 4. Okay, and now I will show you something special. So what I will do, I will simply stop this query. Let me just click on interrupt. Click on yes. Now this query is interrupted. Very good. Okay, very good. Yeah, very good. Good job. Let me just run this insert into command for one more time. Okay, let me just do it. Perfect. Now, now, perfect. Obviously, this is stopped, so no data is inserted. That's what I want. So I will just check the versions now. Obviously, you will see version 4. Okay, obviously, you will see version 4. Now, I will again insert the data. Let's insert the data for one more time. Let's insert it. Now, let me just see the version for one more time. You will see version 5 as well. You will see version 5 as well. Now, this time, what will happen? Query is stopped. Query is stopped, right? If I just again turn on my query, it will automatically read the data from version 4. From version 4. Automatically. Automatically. It will read the data from version 4. Very good. Let me just show you. Let me just show you. That is the power of this reservoir version. But in the initial run, you will see reservoir version 2 because it saves that till this information, till this version, our data is copied. But for the incremental runs, it updates the, let's say, future version that it needs to read. Okay, let me just start this query for one more time. Let me just start. Let me just start. So now again, stream initializing. Okay, now it will just read version 4 and version 5. That's it. That's it. That's it. You will just see 4 and 5. And don't worry, I will just validate as well. Don't worry. Because so far we have, I think, inserted data 2, 3, 4, 5. Yeah, 4 times. So you can see that. See raw data. Now, what reservoir version you should see? Tell me the answer. It is 6. Let's see. It is 6. Let's see. So just check the reservoir version. Perfect. It is 6. That means now the version, now you know this thing. I spent the whole day. I spent, I think, almost like, 10 hours to actually get the concept. But now you know. Just comment down right now. Just comment down right now. Otherwise, do not talk to me. Do not talk to me. So, reservoir version 6. Now you will say, hey, what is the advantage of this? What is the advantage of this? Because we know that it will be just incrementally reading the data. Let me just tell you what is the advantage of it. Let me just tell you. Let me just stop this for one more time. Okay. Let me just stop this, interrupt for one more time. Okay. Very good. So the advantage is, okay. First of all, let me just show you how many records do we have, because we need to validate this information before actually showing the results. Otherwise you will say, hey, we do not trust you, blah, blah, blah. Huh. Okay. Select asterisk from, and what is the path? Path is this one. Let me, who is texting? No one. Ansh, no one texts you. Why do you feel so special? No one texts you, bro. Okay. Now let me say delta dot ticks. Again, I'm repeating, this is not double quotes, this is ticks. This is not single quote, this is ticks. Ticks are available just above your tab button, okay, on your keyboard. Okay, so this is the data. Let me just query this. I have 12 records. Very good. Now I will just show you something special. Just hold on. So what will happen? Now I will insert data 3 times. 3 times. Just count. So 1, done. 2, done. 3. Perfect. How many versions should we see? 6, 7, and 8. Obviously, let me just see. 6, 7, and 8. Okay, 6, 7, and 8. Now. Let's say, due to any reason, I do not want to read 6 and 7 versions of data due to any reason. Let's say we got corrupted data, we got any garbage data. I do not want to read that. So in that particular scenario, what we can do, we can simply go to our read statement. Okay. And then I will simply say dot option. And then we have a function. We have a function called, and this function is used to actually start your streaming query from a particular version. It will not start your query from 6th now. You can change it. you can change it. Let me show you. Simply write starting version, and version that I want to read from is 8 because I want to skip the version, right? And let me just move it before table, because obviously we need to just put it before table. Perfect. So now I am just running this, and you will see what you will see, that error. Oh, because I have just added 2 dots. Let me just run it. Perfect. Now I am just running this query, and this time you already know that we have just 12 records. 12 records. And this time we should only see 15 records because we will be just reading this version. That's it. That is 8th, not 6, not 7. Perfect. Let me just hit this right stream. Let me just hit this. Let me just hit this and let me just show you. And you also know this time that reservoir version will be 9. Okay, that makes sense now, because now you know. Now you know everything. Okay. So perfect. Let me show you the raw data. Okay, perfect. Reservoir version is 9. Reservoir version is 9. Very good. Are you ready to test that what I have, whatever we have done? Let's see. We should see 15 records. Finger clue grow 21. Yeah, I think that makes sense, because this particular query is already this query is already initiated, and to test this particular one, so what we need to do, we need to create a new data frame, in order to do this. And what we can do, because this query, see, this query is already linked to this one, so let me just create a new df.write statement here, and let me just copy this here. I will simply say df new. Okay, and let me just copy this code here in the same cell, then df new dot write. Okay, then df new dot write, and this time we just need to change the folder name as well, data new. So what will happen, by the way, we can simply change the checkpoint location, or obviously checkpoint new. Okay, checkpoint new, data new. Perfect. So this time you will only see 3 records in the new table. I'm so sure you will not see 21 records, because in the source we have 21 records, but you will simply see 3 records. Let's see. This time we should not see any errors, but yeah, it's a part of the process, bro. Do not feel sad whenever you see errors or whenever you do not see the desired results. So as you know, the reserve version is, where is the reserve version, is 9, because obviously we have just read the data from 8. This is fine. Let me just test it. Okay, now this time if I just go here to query my data, and instead of seeing 21 records in this table, I should only see 3 records. Perfect. See, you should only see 3 records, because you have defined that which particular version you need to read data from, instead of reading the whole data. Perfect. Got it. Very well done. Very well done. Now I will just tell you how you can just break your query, because now I want to break this query. Why? Let me just tell you. So what I will do, first of all, I do not need this particular, the new one, because I just wanted to show this particular scenario. Or let's say just close the previous one, because I don't want to run 2 streaming along this single notebook. Okay, so this is my new query that is running. So let's say this time I want to update any record. Instead of inserting any data, I want to update the record. Let's say, so this time I will simply say update table name delta source, and I will simply say set name equals let's keep a new name. Let's say iron where id equals to 1. Let's say I want to make this change. Okay, let me just run this, and you will see this streaming query will fail. Let me just run this. By the way, I have not changed any schema. I have not inserted any new column. No, I have not. I have not. Still, this will fail. Why? 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 So this is fine, and you will see this is already broken and this is already stopped. Why? Because it is saying it is the rule of Delta Spark streaming that it does not accept the changes. Why? Because if you know a little bit about Delta Lake, by the way, if you do not know about Delta Lake, I will strongly recommend to just go to YouTube, okay, and just type Ansh Lamba Delta Lake, okay. Then you will see this video, this one. Let me just click on this, or let me just go to the videos. So this is the, where's that, yeah, yeah, this one. This is the video. If you do not know about Delta Lake, tombstoning, data versioning, time travel, you should just watch this video, because now I'm just using that term, so you should know about it. And this video is your game changer, because no one is talking about open table formats, and that is the future of data engineering. So you should just watch this video and you should become a pro in Delta Lake. Okay, so what happens when, let me show you. So when you just go to catalog, okay, when you just go to dbfs, file store, delta source, sync one, and within this data new, within this we have delta log here. So here we have one version of this JSON, okay, only one version of JSON. That's fine, okay. If you just go to source, okay, let me just go to the source, because from there we are just inserting the data. Source one. So this is these are all the partitions so far. Click on delta log. So in the latest version of this JSON, it is written that tombstone or soft delete the previous partition and insert the new partition. But just tell me, this delta streaming will say, hey bro, I have already inserted this partition to my destination. Now you are saying this is not needed. I will not do that. I will not do that. So Spark, or let's say Delta Lake, will say, okay, do not remove the partition, but at least insert this one. Then it will say, okay, I will do that only and only if you will say something called as option ignore changes. Then it will say, I will ignore the changes. I will simply write the data, but I will not remove any data, but I will simply write the new data with the changes. Okay, so now you will see that we simply need to say ignore changes true. Okay, now if I just write this, let me just see number of records, because I want to show you something else as well. So far we just have 3 records, I guess. Yeah, perfect. So now how many records you are expecting? How many records? You will simply say, hey Ansh Lamba, according to this logic, it will simply insert the partition, insert the new partition. Yes, you are right. So instead of seeing 3 records, you will see more. Let me just show you. Let me just initiate this query now, and it should run fine. Where is that? Yeah, here. Let me just run this query, and let's see what we have. So this is stream initializing. Let me just see the raw data. Okay, let's see reserve version 10. Oh no, we still have 9. Oh yeah, obviously we have 9. So reservoir version, this time 10. Now it is refreshed. Okay, now let me just click on this. Let me just run this. You will see so many partitions. What exactly happened? Like 24. Why? What exactly happened? So basically it has just read all the partitions, okay, and it didn't remove any partition. Okay, if you see here, where's that query? Okay, if you see here, so now this time it will simply read all the partitions, and you will see this thing 24. So basically in the latest partition, our 3 records are added. Okay, our 3 records are added instead of just updating the existing one, because it does not change any value. No, it does not change any value. it will simply insert the partition. Okay. Okay. Very good. Now, if I just insert any data, let's say this updated one, let's say I want to update another record. This time I want to say make update with ID equals to 2. Let's say. Okay. So this time you will see that query will not break. So just allow some more time. Simple, and you will see it is still running. Perfect. And you will see dashboard data is going up. Raw data and versions should be here 11 very soon when it is refreshed. Yep, it's now 11. Very good. Now you will simply see query didn't break. Okay, sorted. Now, before ending this part, let me just tell you what are deletion vectors. So basically the thing is, what are basically deletion vectors? So if you will see our JSON, let me show you. Go to catalog and go to dbfs, file store, and then delta source. Yes, then source one. Then this is the delta log. Just click on it. Just click on it. Just click on it. Just click on it. By the way, one more question, which is out of syllabus, but not out of scope. No. Everything is inside the scope. After 9.json, why do we have two files for checkpoint, like two files for 10? One is for checkpoint and one is for like normal JSON. So the thing is, you will be saying, Ansh Lamba, every time when it again, like you need to just watch that Delta Lake video that I just shown. Okay, then only you will be just be relating to this part. And I don't know why you are just waiting for that video, bro. That video is a gem. Trust me. So this particular thing is called checkpoint. So what it does, whenever it gets 10 JSON files, or let's say 10 updation in the table, 10 transactions, it just creates the summary of the previous 10 transactions. So instead of now writing, let's say this is my 10th JSON, and let's say I updated data for one more time and it will create 11.json. So instead of reading 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, no, it will simply read 10 checkpoint, because 10 checkpoint has the summary of all the previous transactions. Then it will simply read 11, 10 and 11. That's it. Was it good? Yeah. So the thing is, why deletion vectors are needed and why do we need them? This is a kind of different scenario, but this is more than a scenario. This is a concept that you should know, because this is a recent addition. And obviously, if this is a recent addition, this is a hot topic. This is the hot topic, and this knowledge can just make you an outlier, because not everyone knows about it. So the thing is, what happens? This is your partition. These are like all the partitions. Okay. So every time, let me just show you here without any kind of thing. Like let's be very raw. Okay. Let's be very raw. So what it will do? Let me just tell you, bro, because now before ending this video, let me just give you another important value. So let's say this is your source. Okay. Like let's say any kind of storage where you're just inserting the data. Okay. So when you like, let's say these are your partitions. Let's say this is your partition one. Okay. Let's say in this partition you updated a record. So before deletion vectors, what Delta Lake was doing, let's say you just made a change, just one change. So it used to create a new partition, okay, with that change, and it used to say that do not use this partition, use this partition. It was so costly. Why? If I'm just making one change, a change in only one row, I have to rewrite the whole partition. But now after deletion vectors, what actually happened? So let's say this is your data. Okay. Now you made a change in this partition. Okay. So what it will do? It will simply create partition with only one record. That is the changed record. Okay. So now how tombstoning will be taking place and how it will just do that. Let me just tell you what it will do. It will go to Delta Lake, like Delta log, transactional log, and it will simply say, hey, remove this partition. Ansh, this is holding our data. If we remove this partition, hold on. hold on. It will say remove this partition. Okay. Add this partition. Okay. So far we just have one record. Okay. It will say add this partition, this one again. So it will say, why did we remove it? Wait, hold on. This time it will use something called as deletion vector. So along with this partition information, we will also have something called deletion vector in which it will mark that particular record as changed. So whenever delta log will be reading the data, it will not read the changed record. This is called soft deletion in deletion vectors. So this way you do not need to rewrite the partition. So you are saving a lot of cost. Second thing, what it will do, you will simply say, hey, it can create the problem of small file problems. You are absolutely right. So for that, deletion vectors automatically applies something called as optimize. So if you do not know about optimize, again, everything is explained in detail in that particular video. That's why I told you, bro, you have to watch this video. Okay. So it will by the way, who are like my lovely data family members, they have already watched it. So now optimize. So what it will do, it will simply merge both the partitions and it will simply say, hey, just use this new partition, forget about this one, and this was already forgotten. Simple. Because this is the new one. Simple, right? Yes. So this is your deletion vector, and now I know you have understood all the things. So this video was all about real-time scenarios, all about combining Python, combining all the modern structures, Delta Lake, streaming, everything. I tried my best to just provide you the real skills. And by the way, I have already mentioned this many times. So now you can see this lovely button, which is join. So if you want to become my loyal data family members, and if you want to support my hard work, because you know that I'm just spending a lot of time, a lot of efforts, so that you do not need to pay thousands of bucks to those, I don't want to say anything, but you know the reality. So I don't know, like, if someone is doing so much, okay, and why you are waiting to support that particular person, I don't know. So if you really want me to continue posting these videos, obviously you need to support me, you need to support this channel. It takes a lot of efforts. You already know, I do not need to repeat this thing many times, because you are also human beings. You know how long it takes to just create these kinds of videos, right? And I just need your support. You just need to support this channel. Okay. So it's a kind of request, you can say, and I wouldn't say it's a request, because I don't think so. The love, the bond that we have created, I need to request. Okay, so it's just a kind of, you can say, message that I want to convey to my lovely data family members. So just click on join. Obviously this will motivate me a lot, bro. So again, just a message to my lovely data family members, and just click on the video coming on the screen, which is like Delta Lake. This is specifically made for you, and I will see you there. Love you.